Hello, my name is Stephen Thomas, and this is the first video in a series of videos all about Azure Integration Services and hybrid options. I'm going to walk us through all the core components of Azure Integration Services and see how we can use them to build enterprise-grade solutions. This first video is titled Introduction to Azure Integration Services. I always like to start off all my courses thinking about this quote. I had to do an essay about this back in college, and it's something that's always stuck with me. And it's the only true wisdom is in knowing that you know nothing. And this really relates well to Azure because services in Azure are constantly changing. If you look back when components first came out more than 10 years ago, you had a core set of features available. Now there's over 150 different services available for us to work with. Let's dive into a little bit more about BizTalk and the state of integration today. Integration, in my experience, still seems to be in demand. Customers are still wanting systems to talk to each other, both on-premise and in the cloud, and then have these systems sync data back and forth from on-premise to the cloud as well. It seems, though, that full-time salaries are up, so full-time resources definitely are in demand. But my experience is freelance and independent contractor rates seem to be going down a little. I think as more and more people are working from home, that gives a much larger pool of talent to choose from, thus bringing down the rates. Clients are moving to more SaaS-based systems, a lot of cloud-based systems. And this is providing new interfaces and new requirements for integration at those companies. So that's a plus as more and more things move to the cloud, because most clients still have legacy systems in their data centers. SaaS providers are causing a lot more hybrid interfaces, so they want to talk back to these systems they still have in their on-premise data centers. And one thing I've noticed is BizTalk is slowly being replaced. So we're at the current edition of BizTalk 2020. And they seem to be moving to other solutions. A lot of them are looking at Azure Integration Services. And that means it's a great opportunity for Azure Integration Services as we want to move away from our on-premise BizTalk server into more of a cloud-based model. So what is Azure Integration Services? Well, according to the Microsoft website, it's there to build new integrated solutions that connect applications and services on-premise and in the cloud. And that makes sense. It's there to bring your business workflows together so they can be consistent and scalable. That sounds good to you. And last, they say it's to expose your APIs for developers, create opportunities for new business models. So these are the three core building blocks that Microsoft says make up Azure Integration Services. So really, what is this? Well, it's essentially a marketing bundle. Microsoft has put together a collection of services in Azure and said, we're going to market these as Azure Integration Services. And I'll tell you, it really helps open up conversations about Azure Integration Services. Prior to the kind of introduction of this concept, you'd have to go in and talk to a client and say, we're going to implement logic apps, we're going to implement service bus and different components like that. And if they're an existing BizTalk server customer, it could be challenging for them to understand the a la carte model of the cloud offerings. So with BizTalk server, you knew what you were getting: an orchestration engine, a rules engine, a workflow, etc. And now it's pick and choose a la carte. So bundling them together and calling it Azure Integration Services has really helped clients understand kind of the core components that they need to use for their integration solutions. Now, that said, you don't buy Azure Integration Services itself. It's not its own SKU or billable entity. It still is a collection of independent a la carte services, but now just kind of marketed together as one unit. So what are the core services that Microsoft has bundled together into this Azure Integration Services? First is Logic Apps, which is going to be your workflow engine, plus all of its connectors to all its third parties. Next is going to be Service Bus, which is going to be your enterprise queuing and messaging service in the cloud. The third one is API management, which can help serve as a gatekeeper into your Azure enterprise, front all your services, do a tremendous amount of routing of HTTP requests through API management. It's an extremely powerful service, and we'll just barely touch it in these recordings. Event Grid for eventing and real-time reaction to activities in Azure. Azure Functions, which is microservice units of work to do repeatable tasks in the enterprise. So that's the fifth service. And the sixth service that's kind of bundled together is Azure Data Factory for more bulk data loads, ETL type transformations. Now, along with these six core features, there's a lot of other features and services that I think of as supporting features. You're by no means limited to just using those 6 that Microsoft bundles together. You can use anything in Azure to build integration solutions, but these are the core ones that you're going to see a lot of times when working with Azure. First is going to be integration accounts. And if you think back for a while, 6 or 8 years ago, there was a BizTalk services or something like that. Azure BizTalk services, I think is what it was called, which was B2B functionality that was being ported into the cloud. A lot of that has kind of been converted into these integration accounts. So integration accounts in Azure today hold your schemas and your maps and then do B2B transformation, EDI type of work, AS2, stuff like that. Very powerful features. We'll go into that in a whole nother module. Blob storage is a great place to store large amounts of data. It's relatively cheap to store in blob storage, and a lot of times we'll see it used with a claim check pattern where you have a larger message. Don't need to process that message through like the service bus and your logic apps. You just want to put that in blob storage and then can pass around a reference to that message. So we see blob storage a lot. Hybrid connections, also called relays. Relays is the older term. This is a way to securely expose on-prem services to the cloud. Some of the other things use hybrid connections under the covers. So it's a cool little feature out there. Key Vault, which is going to be your secure store for name value pair data, will also store certificates. So when using integration accounts, you would put your certificates inside Key Vault. The on-premises data gateway, this allows you to have your Azure-based resources connect to on-premise data securely via their gateway. The gateway is installed on a server in your enterprise, and then you connect it to Azure and can expose services that way. We'll see a demo of the on-premises data gateway. It's pretty cool stuff once you see that working. Log analytics is also a common supported feature. This is used for logging and tracking things even across multiple Azure services, so they all support log analytics. And some of these features have been around for a very long time, like the on-premise data gateway has been around since July of 2016, and it's pretty much into, I think, a monthly or so update cadence. So they update that frequently, and it tends to be one of the services a lot of people haven't heard about or used much, but is very powerful and is definitely something we're going to take a look at from an integration perspective. So why should you care about Azure integration services? A lot of people are like, I'm getting rid of BizTalk, why should I care about any of this? Well, I asked ChatGPT to write me a class in C#, and I wanted to use remove special characters from a string, XML encode it, and then put it into base 64. And ChatGPT spits out a class. I simply hit copy, and I can go about and use this code. It's just given to me. But I asked ChatGPT if it could create me an Azure Logic app, and it says it doesn't have direct access to the Azure portal or the ability to create resources on my behalf. So this should be a great place for us as developers, knowing that at least for a little bit, not yet, it has access to do this for us. We will be able to have a place to build these low-code solutions with Azure integration. Hello. I'm Stephen Thomas. In this video, we're going to talk about BizTalk and Azure hybrid options. And this is part of my larger series on Azure integration services and hybrid options. Let's dive right in and talk about BizTalk Server and the state of integration today. BizTalk Server 2016 and earlier are completely out of mainstream support. When you think back at BizTalk Server 2013 R2, it has extended support that ends on July 11th, 2023. BizTalk 2016, regardless of your feature pack, has extended support through January 11th, 2027. And BizTalk 2020, which a lot of clients are using today, its mainstream support has been extended and ends April 11th, 2028, with extended support ending a couple years later. In my opinion, completely my opinion, I do not think we're going to see another edition of BizTalk Server. If we do, there'll be very little updates and enhancements. It'll be more just to extend the support dates and to give you the option to use newer Visual Studio tools for that. So as of right now, I think BizTalk 2020 is going to be the last of our BizTalk servers. So where does that leave us with our on-premise BizTalk servers? And now, as we start to think about Azure integration services, what services are supported directly by our BizTalk server? So let's take a look. Logic Apps. So Logic Apps is the workflow in the cloud that has access to hundreds and hundreds of connectors to interact with third parties. So BizTalk Server 2020 has direct support for interacting with Logic Apps. There's also Service Bus. BizTalk Server can read and write messages to Service Bus queues in Azure. There's Blob Storage. So just like Service Bus, BizTalk can read and write to Blob Storage in the cloud. And also Event Hub. So BizTalk Server can receive events in from Event Hub and then write events from BizTalk Server into Event Hub, which is just native support built right into BizTalk Server. So why would we want to think about Azure hybrid solutions? So it would allow you to reduce or remove a lot of your on-premise resources. So as you think about moving from your BizTalk environment to cloud-based solutions, things that tend to cause you problems on-premise, like text config files, FTP endpoints, file drops, having to set up that reverse proxy to have communication back into your data center, and really just running BizTalk server itself can be challenging and always a point of issues in your environment. All those can be replaced with Azure features. Some of those would be like Key Vault, which will allow you to store your passwords securely. Service bus queues allow you to have that in-order, dependable delivery of queuing messages. And then API management to kind of be your gatekeeper in. Definitely a lot more user-friendly than setting up a reverse proxy. So why is now the right time for you to start thinking about Azure integration services? Well, really, if you think about it, we will never have more BizTalk experience in the world today than we have right now. When you look at new developers that are coming into the workforce, I don't think there's a single one that's jumped up and said, hey, I'm going to jump in and do BizTalk server. That's just not where talent is going these days. And with that said, more and more people with that BizTalk experience are moving on to other initiatives. Whether it's cloud initiatives, moving up into management, they're leaving their BizTalk skills behind. So never going to be more experience with BizTalk right now if we want to look at moving those solutions away from BizTalk server. Like most companies, clients are walking away with domain knowledge. The client will have a few developers and business analysts that are really good at understanding their BizTalk interfaces and what they do. But just like everything else, those people get promoted, they change jobs, they change departments, and clients are losing that domain knowledge for what their integration solutions were supposed to do, and then have to reanalyze that, which is probably a good time if you're looking at moving integration anyways, to kind of reevaluate the business needs. But it's definitely easier if you have the people that originally made those decisions there. So continue on. What now is the right time? It's a great time to just stop and say, what are my integration strategies going to be now and in the future? What are my needs going to be? Are we going to have cloud services we need to talk to? And really now is a great time to stop and think, what is our strategy going to be? 15, 20 years ago, the great strategy was, let's use BizTalk Server, be our strong on-premise solution for integration. That strategy isn't going to be very valid now, as we're looking at more cloud-based integration points and clients even totally getting away from their on-premise data centers. So great time to reevaluate our strategy. Let's talk about some architectural scenarios that are going to exist with our BizTalk server. It's still an option with that. So what can we do with this BizTalk server that's probably very mission critical if you still have BizTalk server running today? First, this was an architectural approach taken longer ago, I'd say more common 5+ years ago. It's just a hardware lift and shift, where you're going to take your on-premise BizTalk server and SQL, move them to Azure in a virtual network, and run them on Azure virtual machines. This is definitely a viable solution today. Doesn't solve your problem of running out of mainstream support a few years down the road. There are some benefits of this: no rework or development. You can scale up and down virtual machines that's needed in Azure, so you can reduce those resources in your on-premise data center. Take full advantage of all the Azure services, virtual networks, stuff like that. And, as I said, reduce some of your on-premise resources. Another architectural scenario is to do new development only in the cloud in your Azure components and slowly move your BizTalk solutions over as time sees fit. Eventually, though, you're going to run out of time with that BizTalk server 5 years or so from now. And it was going to result in the maintenance of two separate integration environments and kind of having to understand both. But it does give you a way to start moving into things slowly. So the benefits of this is generally it's the easiest to sell when I'm talking to a client and going through different options. This one seems to make the most sense. It gets developers up to speed at their own pace, and then look at moving BizTalk services over as it makes sense. The third scenario is going to be time to upgrade BizTalk server. So let's go ahead and do a full rework and migration. I worked with a client that did just this. I think they were running BizTalk 2013 or 2016, I guess it was, and looking at moving to BizTalk 2020. Instead, they decided to make the move from BizTalk server to Azure integration services. And it worked really good for them. It was a long project, multiple years, because they had a lot of endpoints. But you would approach it as you would any other migration. You would work on your critical resources first, get them into the new environment, and then move over all your other supporting services as it sees fit. The benefits of this is you get to leverage the full features of the Azure cloud. Most clients will actually see a cost reduction in the amount they pay for Azure integration services compared to BizTalk server licensing and running it in their own data center. So there could be some benefits there. Fully retire your on-premise assets. I think everyone's super excited when they can go in and shut down that BizTalk server for the last time. And plus, that means you never have to install BizTalk server again, which is definitely, I consider, a plus. It gives you the ability to fully grow into other Azure services as your needs arise for those. And as I mentioned, you could have a cost savings because a lot of clients do find that the Azure pay-per-use model is a cost savings there. So really what I like to try to rephrase this as integration reimagined. So before we were focused on this box, this BizTalk server environment that we had to play with, and now we can be a lot more creative. We can do a lot more different things with our integration, and we have a lot more different services available to us, and we don't have to use them all. So I really like to think of it as reimagining the way we do our integration. You do have to make sure you find the right balance, though. The right solution is not going to be the same for everyone. You want to make sure you always follow your corporate and government data requirements. Look at what Azure data centers you're using, where they're going to store their data, especially if you're outside of the US. There may be different government regulations around where that data physically resides. So you want to keep some of those things in mind when you build your solutions. So you really want to stop and look at what your integration is doing today, and then just remodel that and think of how to map those existing components to Azure services. Like BizTalk orchestrations is going to generally map to logic apps, but it doesn't necessarily have to. You don't necessarily need a logic app if you had an orchestration doing that before. You might be able to solve that problem with API management and service bus queues, or if it's a lightweight solution, functions even. So there may be different ways than a direct migration from orchestrations to logic apps to solve your problem. Don't try to force a solution. I've worked with some clients that would say, oh, we have this talking to two different servers on premise. I can either send that data up to the service bus and run it through a logic app and send it back just so that all our integrations are in the cloud. Well, that might not always be the best solution. I would kind of consider that forcing a solution. You might want to look at keeping some on-prem services running if that's the kind of thing you're looking at doing. Don't take on too much at once. So if you are going to do a full migration, don't start with everything at once. Start and fast track one interface because you're going to learn a lot from that first migration. It is a lot of work and it's a lot of learning. You get to learn new things in Azure, which a lot of people can get excited about. And if you're an existing BizTalk developer, everything's going to make sense. As you look at logic apps and service bus, these are concepts that you work with every day working with BizTalk server. So things are going to make sense for you in the cloud. Hello, my name is Stephen Thomas, and this video is called General Notes on Azure from a BizTalk developer point of view. And this is another video in my series related to Azure integration services and hybrid options. And what I really want to do here is spend just a few minutes going over some things that I've learned right away when I first started working with Azure that really helped me out kind of get accustomed to Azure, definitely from an on-premise BizTalk developer perspective. So let's dive in and take a look at some notes. First, I want to talk about being an Azure pricing architect, which if you're coming from a BizTalk background is definitely not something we're accustomed to. BizTalk server, you buy BizTalk and you pay a licensing fee and you get X amount of services included in that. You get a workflow engine, you get a rules engine, you get a mapper and stuff like that. With Azure, you really have a la carte model and picking and choosing what services you need and want to pay for. So this is going to be really our job of the future. As we look at moving components into Azure, we're going to have to really understand the price impact of the technologies we choose. Something else to keep in mind is that I've noticed pricing tends to change every now and then. Some things stay consistent for years and years, but some things like storage, kind of, and compute is kind of one of them that actually tends to go down over time. I guess as new, stronger compute VMs are released, the older ones are less relevant. There's some things that start off in preview, especially when you look in the Azure portal, you'll see a lot of things in preview. Generally, things in preview are free, so keep in mind that they might not even have a pricing model talked about yet. So when they move out of preview, to make sure you understand what the price of those features are going to be. You can also look for developer priced options. So there's bigger services in Azure will have like a developer version. So like integration accounts, for example, have a developer edition that you can use at a discounted or free price. Not all developer systems are cheap or free, so keep that in mind too. And do understand the limitations of your developer artifacts that you're working with. As I mentioned, not all developer systems are cheap. There used to be an integration environment that as a developer edition was still hundreds of dollars a month. Azure's features and services are going to vary a little bit by region, especially if you're working in some other cloud versions like the government cloud. Services tend to release in a couple core regions first, and then they're spread across other regions in the US and then other regions in the world. So if you're a lot of things you'll look at, especially in preview mode, you'll see that it'll tell you what regions they're available in. So not everything's available everywhere. Just kind of keep that in mind. And pricing can also vary by region. So if you're doing things in the US versus things in Asia Pacific or Australia, the pricing is going to vary for your services based in those regions. Something else I like to talk about, again, not something that we really had to ever focus on as an on-premise BizTalk developer, is what I like to think of as just-in-time architecture. So what this really means is I'm going to design a solution as best I can with the artifacts that I have available today. That means I'll have logic gaps, I have service bus, I have API management, stuff like that. Some of those components like API management, we didn't have access to 5 years ago, at least not in Azure. So I'm going to architect my solution just in time using the components that we have available today. You want to decide with this if you want to use those preview features. There's a lot of new and exciting things in preview mode. They're generally safe. I've had experiences long ago, 7, 8 years ago, where some parameter names would change on some preview features, but we weren't leveraging preview features in production. This was just in our test environment, so I was able to capture that. And we did move things into production as they came out of preview, though. Support may vary if they're preview features, so you want to understand that impact. And some preview features never come out of preview or just quietly drift away. So not sure what the guaranteed level is around if they would ever go live or not. So you want to keep that in mind. Another thing I've noticed is I've built some logic app solutions 6, 7 years ago, still in production today, working just fine. Well, is there a time and place to relook at those and rework those solutions using these new features? As I mentioned, APIM wasn't available then, but it's working just fine in production now. So there's probably no reason to spend money and time to go back and retrofit older solutions as long as they're meeting the business needs today. I would tend not to rework solutions. Otherwise, you would constantly be refactoring your work in Azure as new services came out. Obviously, if there's a business need for it, then you'd want to address it at that time. Some more general notes on Azure itself. The only thing I've noticed that's consistent is inconsistency. So, and really what I mean here is things constantly are changing. New services being added, the designers are being updated, the look and feel of things are changing. So you will see a lot of things that will change over time, especially if you step away for a month or two and come back, you will notice a lot of things that were different. Naming standards matter just as much in Azure as they did in BizTalk Server. For whatever reason, the name that you get in some of these windows to see are so tiny, just like BizTalk Server. So having a defined naming standard is important. Here's a link to one that Microsoft has came out with. There's several others out there. The only wrong naming standard, in my opinion, is to not have one. So come up with the naming standard and try to follow it through. That said, when I do demos in some of my other videos, I'm not very good at following a defined naming standard for my demos. So I should just embed that and try to do that better. Building your solution is only about half the battle. So really the key to Azure, much more so than when we had BizTalk Server on-prem, is the DevOps side of Azure. That will really allow you just to easily move things from your development environment to your QA to your test environments and then eventually into production. And allow you to be able to rebuild all those components if there's a disaster, you need to change regions, change data centers. Having a well-defined DevOps process takes a lot of time, but is really the key to having a well-built Azure integration solution for your enterprise. So don't overlook the DevOps side of things. And it's not easy, especially on the logic apps. If you've worked with binding files and BizTalk Server, I hate to say it's a similar story to binding files. Look and feel conceptually is very similar to binding files in BizTalk. But now you have essentially configuration for logic apps, service bus connectors, all kinds of things that you have to keep track of. The story in DevOps is getting better every day, so it's a lot better than it was years ago, but just keep in mind that there is going to be a substantial amount of effort put into the DevOps side of things. I found having more than one Microsoft account tends to cause all kinds of issues all over the place. I work with a bunch of different clients. I have a bunch of different Microsoft accounts for many different clients and constantly have issues signing in and out and switching accounts to the point where I would come up with virtual machines that I only use for certain clients just to keep everything nice and clean, working with multiple Microsoft accounts. Architecture in Azure is more than just the technical solution, it's more than that technical piece, because now we have that pricing component to things. So you could have a beautifully architected solution using enterprise service bus and logic apps that pull every 3 seconds. And then you end up looking at the cost of that solution, and it could be thousands and thousands of dollars a month for something that might not need that kind of level of servicing. So want to make sure more than just architecture, keep that price in mind, which is going to be kind of a new thing for a lot of people to start thinking in the back of their minds. There's a cost there. Not everything comes out of preview, so I want to make sure I mention this again to keep that in mind. Something else I've started to run into problems with, gosh, I guess 25 years ago, but there are these two brothers created this great site called hotmail.com. I set up my Hotmail account. I've used it ever since as my main email account. Microsoft bought them a few years after they opened, and now it's part of Microsoft. So just recently, past 2-3 years, I've been having a lot of issues when I'm using my Hotmail account with Microsoft services. I'm sure you've all seen when you log in, are you a work or school account or are you a personal account? A lot of things are not liking those personal accounts. BizTalk 2020 and connecting to Azure is one of them. It doesn't like using that Hotmail account for that. It doesn't have to be a work or school account. So keep that in mind. I'm slowly transitioning away from my beloved Hotmail email, but keep in mind if you're using that, you could run into some potential problems. Something else I want to mention here is serverless versus not serverless. So serverless is still there. It was this huge buzzword, about 10 years ago. Everything was serverless. Functions were serverless. Logic apps serverless. Pay-per-use model was great for us developers. We could build all these beautiful services. If they never run, we never pay a cent for them. That's fantastic until the business gets involved and said, well, we need a more predictable model for what we're going to be charged for our interfaces that you guys are building. And we're saying, well, it's serverless, it's pay-per-use. That didn't always go over well. So definitely serverless is not as strong a buzzword as it was a few years ago because of businesses wanting to move to this fixed compute model. So serverless is still there. We'll see in other videos. We still have serverless for functions in our logic apps that we can use. Things in Azure in general, though, tend to be moving away from kind of the serverless style into things that I guess I'd consider an app service environment. An ASE is what they call it. And what these are fixed units of compute. Think of it as a virtual machine. And these guys are scalable. They can't have isolated resources. I think all ASEs will have isolated resources. You can read a lot more about ASEs, find whole videos on them. They go through multiple versions as well. You'll see this in Azure. Those ASE V1, 2, and 3, and there's probably higher than that now. Different ones have different features, do different things, stuff like that. But they're this fixed unit of compute. So instead of saying I have 1,000 logic apps, counting the number of actions and seeing how much that's going to cost me, I can just now pay $150 a month for my fixed unit of compute. What are some other helpful tools? These are things I find that I use quite frequently. There's this little site called http://stat.us where you could pass it in a code /200 and it'll echo you back a 200 response. I find this very useful in testing a lot of obscure paths. I want to know what happens when I get a 404, stuff like that. I find this useful. Logic Apps has implemented some static response templates kind of thing, so isn't as useful as it was several years ago, with something I still use. Postman is a great go-to tool for testing out logic apps and testing out our API management components that we're exposing and stuff like that, so I recommend everyone take a look at Postman. Service Bus Explorer. Service Bus has gotten more and more support with everything in the portal itself, but I still, old school Service Bus Explorer was this little tool you could download. It runs locally. I still like Service Bus Explorer, even though it's I think it's verbatim now in the portal, but I still like my desktop tool. Same with Storage Explorer. Just another tool that runs on your desktop, allows you to interact with your Azure storage accounts. So what are some my last thoughts about Azure and BizTalk? So what you see is, unlike BizTalk Server, Azure is always changing. So constantly getting a refresh. BizTalk Server had a multi-year refresh cadence. Some feature packs came out here and there, but for the most part, Azure's changing very frequently on a monthly or multi-month basis. Hello, my name is Stephen Thomas, and this is another video in the series about Azure Integration Services and hybrid options. This video is going to be a quick look at the Azure portal, kind of from an integration developer's point of view. This is also a look at the portal for somebody who's brand new to the portal and hasn't really worked with it very much in the past. So this isn't going to be a full, deep review of the portal itself, of all its features, but just kind of some key things you'd like to know to get up and running and to help build some Azure solutions. Let's do a quick overview of a little bit more about the Azure portal. The Azure portal, of course, is a great way to make changes to Azure artifacts. The portal's been around for as long as I can remember, kind of working with Azure artifacts, 10, 12 years now. And this came a long way throughout the years in terms of features available in the portal. It first started out that most of the development you would do with Azure was going to be through the SDK or through PowerShell, and then more and more features were moved into the portal itself. They've done a great job now at having a lot of parity between your PowerShell commands and your Azure portal features, so that's a plus. There's also was some tooling around Service Bus that used to only be available kind of through the APIs, and then now they've been moving some of that Service Bus stuff into the portal as well, which is all a good thing. Even some SQL tasks can now be done and execute SQL commands through the portal. So great changes there. You can use a lot of different browsers to access the portal. I tend to use Chrome myself, just has always worked the best in the past over the years, so I stick with that. I think Edge is getting better and better adoption as well, but I tend to not have any issues with Chrome, especially doing a lot of logic apps with the designers that are built in the browser window. Chrome seems to be a good choice for that. The portal does change now and then, so as new features are added, you'll see changes to the portal. Something as simple as like creating a virtual machine that used to be a one-page, one-step process back in the day. Now it's a multi-tab process with virtual networking and disk selections and pre-provisioning, and all that has just kind of changed and evolved over time. So don't be surprised if you log in and see that things are very different. New features are always being added, so as the portal changes, it's a lot of times because of these new features, which is great, because having something new is generally better and enhances what they have out there. And custom dashboards. This is something else that I wasn't very aware of initially. Custom dashboards you can set them up as you wish, add the widgets that you'd like to use, and you can even create these dashboards and share them within your organization with others. So you could create a production support dashboard, for example, or like a UAT testing dashboard, and pre-fill it with the widgets and components that people would want to look at, and then you can share these with other members of your team. So that's a big time saver. So with that, let's jump in and take a quick look at a demo, a first look at the Azure portal. We're now over in the Azure portal, and I've simply logged into my account using one of my work email addresses. If you don't have an active subscription, I think once you log in, you're going to be prompted to create a subscription. There's several free options out there to get some free trial credit to use. Also, if you have a Visual Studio subscription, what used to be MSDN licenses, a lot of those come with free compute usage on a monthly basis as well. So there's a lot of ways to be able to get access into Azure and start building artifacts. When you see here, this will be your main landing page. So you want to get started by going to this gear icon on the top right. When you select the gear icon, you'll see a bunch of different things. If you have multiple directories, which is kind of like multiple companies that you work for, you're able to select a default one and change them here if you'd wish. This is more of an advanced feature, not something we're going to talk about. And what I want to do is go under Appearance and Startup Views. And this is where you can change the core layout of your Azure portal. Different accounts I have kind of have these things set up differently, but you can all go in here under the gear icon, Appearance and Startup View, and make changes. I personally like this menu on the left docked, so I leave that docked. You can select some themes, your contrast, and then you have the ability to change your startup view. What I have it set on now is the home page. If I want to go directly to a dashboard, I can select it here and then select the dashboard that I would like it to go to. I'm not going to change that. I'm just going to leave it at home for now, and we're all set there. So with that, when we go over to our home screen, this is going to be the layout I want to see. If I want to see my dashboards, I can click on Dashboard, and here's just my dashboard, a private dashboard that I have created. You do have the ability to select down here, and you could browse all dashboards. So if I had additional dashboards that I had created, I could see them here. If I had ones that were shared within my organization, I would see them here as well, and I'd be able to select them as I see fit. I'm going to cancel out of this. To make changes to the dashboard, you can click Edit. And then you can add new widgets over here on the right. I'm just going to add a clock, for example. And if there's settings that you can adjust on these, you can come over here and adjust them. Not everything has settings, but when they're here, you'll see them. You can change the size of the clock in this instance, and some settings over here to edit the clock. I'm just going to save this because I want to leave it as is. And then here you can see I have adjusted this dashboard. If I want to create a new dashboard, I come over here and do Create, click Custom if I want to create a custom one, and then give it a name. I'm just going to call it Live Demo, hit Save, and there's nothing on here, so I could click Edit and just add whatever I see fit, drag it on, and I can select where I want it in my dashboard. And I come over here and hit Save, and that's going to go ahead and save my live demo dashboard. Now I can toggle between these. I have some other ones that I've recently created as well, and my default one was this live dashboard over here. Over here on the left, these are the items in your favorites layout. To add things to the favorites, the easiest is to go to All Services. And this is going to list all the services available in Azure. And it does a nice job of organizing them kind of by resource grouping. So like all the AI components are going to be together. And you can simply scroll down and see all the different items you have in here, and you can see some of these are starred. So all the items that are starred are going to show up over here in your favorites menu on the left. Let's just go to Azure load testing, and let's say we want to select that. You select the star. I can select it in this screen as well, or in that pop-up, and it added it down here to the bottom. You can drag and drop these components, move them around as you'd like, and then they'll be reordered as you set fit. And if I don't want this on here anymore, I can hover over it, carefully scroll to the right, unstar it, and now that's going to be removed from my dashboard or on my features list. favorites list on the side. So that's kind of a cool feature I like there too. I like to keep my favorites clean with the items I'm working on. I'll create my dashboards. I generally have core resources pinned here that I use a lot. This shows a whole resource group. I generally don't use that kind of layout. I'll tend to pin specific resources when I'm working on them and then unpin them when I'm done working on them. But this was kind of a high level first look overview. By no means does this cover all the features of the portal, but if you're brand new to working with Azure and doing Azure integration, these are some of the core things that I think you'd like to know to be able to get full advantage of your work time and leverage the portal. Hello, my name is Stephen Thomas, and this is another video in the series about Azure integration services and hybrid options. This video is an introduction to Azure Logic Apps. For somebody who hasn't worked with Azure Logic Apps in the past, or who knows very little about them, this is a great place to start. We're going to cover some of the very basics, and then take a look at a demo showing the very basic, simple things you need to understand about a consumption-based Logic App. So let's get started with a little bit of history around Logic Apps. So believe it or not, Logic Apps have been around for over 7 years now. They've existed in a couple different forms, but the current rendition of what we call Logic Apps is 7 years old now. Originally, it started, I'd consider it a V0, and it was called Azure BizTalk Services. This was Microsoft's first attempt at taking some on-premise BizTalk resources and kind of moving them into the cloud. So they started with EDI components. So there was EDI, AS2 messaging, transformation schemas, the EDI schemas, stuff like that. That kind of morphed into integration accounts, which I covered in another video, but BizTalk Services isn't there anymore in Azure. Then we started to see this V1 of Logic Apps. I'm not sure V1 was actually ever released. It came later after Azure BizTalk Services. It had a lot of interesting features to it, so connectors such as like the SQL connector and stuff like that. You had to self-host these connectors. So you had to deploy an instance of the connector kind of to your Logic app container and then kind of use these deployed resources. You couldn't just grab a connector and go like you can today. This then turned into what we call V2. This is what we think of as consumption-based Logic Apps today. It was very simple. It was the serverless model, so it was pay per use. This was really thought of as this. So this was what came out kind of 7 years ago. Was this release of the Logic Apps? So this was kind of thought of as pay-per-use model that clients would really like. It was nice because if you created Logic Apps and then they were only called once or twice a day, you only paid a fraction of pennies for each of those executions in general for their Logic Apps. Your connectors were now Microsoft hosted, Microsoft managed connectors, so you didn't have to deploy them out anymore. And it made it really nice and able to use a bunch of different connectors. And then Microsoft was responsible for updating and maintaining those connectors. So that was good. A few years, 3 or 4 years after kind of consumption Logic Apps came out, there came a new kind of release of Logic Apps called Standard Logic Apps. This was Microsoft's kind of answer to the unpredictability of serverless. So people love serverless. It was great. And then it was a little bit harder to explain to the business that your bill is going to be variable each month. And I can't really predict to the penny that they would like how much that bill is going to be. So standard edition model came out, supports a more fixed fee pricing model. So you buy like a unit of compute essentially at a monthly level. And we get a lot more into this in another video. But standard can also run locally, which was a big ask. So consumption-based is serverless, run in Microsoft's Azure, and the standard edition can choose to run in Microsoft Azure, or you can self-host and run it yourself. So that was a big plus to standard edition as well. Now there's a few different options between standard and consumption. They kind of each have their own place. It can kind of get a little confusing sometimes. So, really it's a lot of options. Is it always better? Hard to say. But we'll see. We have a whole video on standard versus consumption Logic Apps. So we can dive into it and take a much deeper look at those two. So talk about BizTalk reuse. A lot of people coming to Logic Apps have existing BizTalk server artifacts, generally running on premise. There's some good news here. So schemas can be reused pretty much as is. These are upgraded or uploaded to your integration accounts for schemas, and this includes any custom flat file schemas that you may have created. So this is great at continuing to parse that flat file data in your logic apps. If you are using standard edition logic apps, it's a little bit different. You can upload your schemas directly into your standard edition app service plan, and we'll see that when we dive into that in more detail later. So just understand now you can get reuse from your schemas as well as from your maps. They also upload to your integration accounts or to your standard edition containers, and it allows you to also even use your external assemblies that you may have called within your transforms. There are a few functoids like the database functoid and stuff like that that don't work, and there is a little bit of prep work in general that kind of needs to be done with your maps if you have complex logic in there and want to do logging and stuff like that. There is a great document on this on the Microsoft website. If you just search, BizTalk port into logic apps transforms or something like that, you're going to be able to find it. So it's very detailed about what you need to do. But for the later demo, when we do integration accounts, I just export the XSLT, upload it to the portal, and it just transforms just fine, exactly as is. So you can get some reuse. So that could be a huge benefit of looking at moving from BizTalk. You can get some reuse. So that could be a huge benefit of moving from BizTalk to logic apps. Orchestrations. So at one point there was a converter tool available. I'm not sure it worked the greatest of taking an orchestration and making it a logic app, but in general, if you open up your orchestration and you start building a logic app in the designer, you're going to see that it's going to be pretty straightforward to map those shapes and actions back and forth, just with them kind of open side by side. So let's talk about a little bit of terminology. So triggers, you'll hear about triggers a lot in logic apps, and this is really how they start. There's two main types of triggers. So there's polling-based triggers and there's push-based triggers. So polling-based does exactly what it sounds like. It's going to be essentially a timed process, going to go look for new messages, like in a queue, for example, every 3 seconds or every 30 seconds or something like that. And then push triggers where things are going to call into that logic app. So like an HTTP endpoint, you could call into that logic app to trigger the logic app to execute. We also have actions. So the actions are what does the work inside of a logic app. These are what we call shapes in BizTalk. I will interchange the two constantly, and I shouldn't. It's very well defined that the logic app is an action. So keep that in mind. You might hear me in other videos say it's a shape, but really is an action. Logic apps are actions. It does the work inside there. Then you have connectors, and these inside logic apps are what talks to something else. You'll hear these called API connections at times. The best way to think of these is kind of like an adapter in BizTalk, except there's a whole lot more of them. In BizTalk, we had a handful, maybe 24 at max, different adapters. Here we have hundreds and hundreds of connectors. There's constantly adding new connectors, and we can even create our own custom connectors very easily if we would like. Anybody that tried to create a custom adapter in BizTalk knows that it was extremely challenging to get it done right. It's very straightforward to create custom API connectors in logic apps. So that's cool. The connectors in logic apps do all require configuration. So these are essentially most of them are Microsoft managed, and they require certain inputs. So like API keys or destinations or like SQL connection strings. So all connectors are going to require some sort of configuration. And once you select a connector, then that connector will give you a series of actions and triggers that you can use. So certain, like a SQL connector, will have a trigger like data exists from that query, and it will have an action like delete row or call store procedure or stuff like that. So a given connector will have both triggers and actions. So present day logic apps. We have a couple different models. We have consumption model, then we have the standard model. I'm going to go into these in much more detail in another video, but just understand there are two different models of logic apps. Standard edition does support a stateless workflow, which is nice. So you can turn off the logging and get better performance. And it does support on-prem deployments. This leads us to two different designers. So the consumption model is going to have one designer. Standard edition has a slightly different designer. Look and feel is different between the two, but at the end of the day, they will make the same flows. But the two are not compatible. You can't take a standard edition logic app and directly use it in consumption and vice versa. So that's the two different designers do produce different output. There are several different hosting models. And like I said, we're going to dive into this a lot more in another video, but just understand that the hosting models are going to be different between consumption and standard. And logic apps in general, whether it's consumption or standard, it's really all about understanding the rules. Anything you do in logic apps, you could build and custom code yourself. But what you get with logic apps is the platform that runs the logic apps, does the logging, provides you the designer, provides you that low code experience. And with that, there are some rules. Logic apps, like I said, is all about the platform that it's going to run on. There's limits and configuration references for logic apps all over the place. There's a full list of the logic app kind of workflow, throughput limits, and stuff like that here. The key thing to take away here is that the limits exist to ensure that you don't overrun the system. So, for example, there'll be API limits, there'll be limits in file size. I think it's 100 meg inside of a logic app. And the limits do change over time, generally go up over time. One could question why you would need a 100 meg file in a logic app to begin with, just like people would try to run that through BizTalk. There's generally better ways to do it, but just understand there are some limits and configuration items you need to understand. Most of the limits are absolutely nothing to worry about, like the 100 meg file size. And you'll find that different connectors will have different limits in terms of file size and stuff like that as well. So understand that the limits aren't just at the logic app level, they are going to be per API connection as well. The API connections, the most common thing you'll run into is rate limiting, and that's a status of 429. And this is when the Microsoft managed API is saying, hey, you've called me so many times, let's slow it down a little bit so that I don't overwhelm the API connector or your backend system. So 429 will be something you will see. And as you look at each connector, the documentation, it will tell you how many API calls are allowed per minute or per time interval for that call. Thing to keep in mind is this is per API connection that you create. So if you have multiple connections to even the same SQL database, those would have different rate limits. It's just when you use the same connection across the board, those are all pooled together for your rate limit. And we get more into API connections in another module as well. But just keep in mind that these throughput limits aren't for the connector as a whole. It's at your individual instance of that connector that you're making that connection with. Okay, with that, let's dive into a first look at logic apps. We're going to jump in and I'm going to show you just a little bit of the basics around a consumption-based logic app. Okay, I'm over on my virtual machine in my Azure portal. I'm just going to go ahead and create a new resource. And we're just going to show you some of the basics of logic apps. So to find my logic apps, it's right down here. I could click logic apps. Over here under my favorites, I have logic apps tagged as well. Or you can go up to the top, create resource. There's many different ways to create resources. I'm just going to click on logic apps. And here I have the ability to select some information about this logic app. I can select what subscription I would like. I'm going to leave that there. I can select a resource group. Let's just create a new one. RG live demo for YouTube. And I can give the logic app a name. First look at a logic app, and I'm going to say it's a workflow. I can select the region that I would like to put this logic app in. I'm just going to select, leave it the default East US. And here I have the ability to select the plan, the type of logic app I want to create. But we're going to focus on consumption right now. So this means this is going to be hosted in Azure and Microsoft's cloud. And let's just go to the next tab over here. And this is where I can add custom tags. So a lot of people will add something like a cost code so that you can do billing back to individual departments, or if you want to be able to see different groupings of things here. This is more from generally more from an accounting and billing perspective. You would organize things into resource groups kind of for deployment and purposes like that. But this is going to be from like a billing perspective. And we'll go to review and create. Here it's just going to confirm that everything is correct. And then you have to click create, and it's going to create that logic app. And it's going to take just a moment to deploy this logic app that I've created. Some Azure components take longer than others. Here I can go to this resource, or up here on the right, I have the ability, if you saw that notice, to pin it to my dashboard. So if you miss these notifications, it's this little bell up here. You can go click on that and you'll see all the notifications. I can pin it to my dashboard if I wish. I'm just going to go to that resource now. And here I have kind of the skeleton running components of a logic app. Over here on the left, you have your deployment tools. So we're going to dive into the designer just in a moment. If I did create connections, they would be API connections listed here. We have some settings for the workflow, authorizations, identity. We won't go into all these in detail, just understand that the settings for this logic app is at the logic app level, not any higher than that. So if you did have settings here, they'd be per logic app. Some monitoring metrics down here, automation tasks, and then your standard kind of help down here. At the top, in the main section, you have overview and your access control. Access control is more useful for other Azure components and sharing access to like service bus queues and stuff like that. But that is here as well. If I had run history, they would be down here. Since it's a brand new logic app and nothing exists, there's no run history. I'm going to jump into Logic App Designer. And this will give you an option to listen to this nice YouTube video if you would like. We can also get started from scratch with these pre-built templates. These are some of the common triggers that you can have. There's also more complex templates down here. So if you were going to do like an HTTP request response, you could select these templates and automatically have some of these API connectors added to your designer surface for you. You can also create custom templates and then upload them and share them across your organization. So if you had interactions with a SQL Server or SAP or something like that, you could create custom templates here for individuals to use as they need it. We're just going to click resource to create a recurrence, trigger for that logic app. So this is how this logic app gets started. Just leave it at 3 minutes, and we're just going to hit save. And this is just to show you that this is now saved, and I have a basic logic app that's going to run every 3 minutes. Now, nothing's going to happen here. You have to add actions under your trigger. I would go new step. And here you have the ability to select different types of actions that you want to add. So you have built-in ones, standard, enterprise, and custom. And a lot of these are going to be Microsoft hosted API connections. So if you go to a standard, for example, it takes it just a moment to populate, and you'll see all these types of API connectors that you can select. So I'll just grab SQL Server, for example, and then you can see here you get the option for all these actions that you can use, or you have triggers, which wouldn't make sense now. I'll have a trigger for the logic app, but you have the ability to select those triggers. So I could also come back and have deleted that trigger and started with a SQL trigger, started a blank logic app and went with that. There is all the options for flow control as well, which is control. So that's going to be this built in. So you have conditions, you have for each loop, scope, shapes, and stuff like that. This is going to be a key one for doing our flow control inside our logic app. Another important one is data operations. That's another good one that you can use for manipulating data and stuff like that inside your logic app. So this one here, data operations, is good. Let's just click on that. And here you have a bunch of different actions that you can do, a lot of array manipulations and table manipulations. The compose shape I like to use a lot. All this does is simply allow you to compose data that you can use later on in your logic app. Something else to point out is you can use information from past actions. As you saw here when I clicked on that shape over here on the right, there would be dynamic content available if the trigger above or the actions above supported it. There's no real data in a recurrence, so that's why you don't see it here. You have the ability to click on expressions, and you have all these pre-built functions that are here. We'll see this in action in some later demos, but for now, just understand that you have all these pre-built functions you have access to as well. I'm going to leave this as is and hit save. And I want to jump over here and show you versions. Well, before I show you versions, let's switch to code view. So this is just your designer surface. Underneath it, much like you saw with BizTalk orchestrations, if you work with them, there's a JSON file, a representation of what this means, this actions, that triggers that I've dropped on this surface. You can see that under code view. You always want to save before you go to code view. If not, it'll prompt you here that says you're going to lose unchanged saves. You're going to lose items that are not saved. If you don't pay attention to that and hit OK, you could lose a bunch of configuration you've done in your logic app. I was talking earlier about that limits and configuration of your logic app, and that same link will outline this whole definition of the logic app. So this is a defined JSON definition of the logic app. You could come in here and build it directly in here if you wanted to, I guess, and not use the designer. There are going to be times you're going to jump in here and make changes to things, and we'll show you that in some later videos, but don't be afraid to jump over here into code view and make changes as needed. Now, it is possible to brick this, so I'm going to just make a change. It's probably not going to like it. And if you, oh, that actually did save. Let's make it invalid JSON then. And if you try to save, it's not going to let you save this. So if you do make a change in here and you end up messing it up, it's not going to let you save it. So you're going to have to fix that change before you go on. The same is actually true in the Logic App Designer. So if you added an action, for example, and didn't add some of the required parameters, you're not going to be able to save that Logic App until you do that. So let's go ahead and just discard those changes. And let's jump over here to versions, because versions are very important. So as I've saved this Logic App, as we went through things today, each version of that Logic App is actually saved here, and I can go back to them at any time. So I can click on this bottom version, and it's going to give me a read-only view into that Logic App. Now, this one didn't really have much on it. Let's look at the next one. This is where I added the recurrence. And let's say I didn't want to add that compose shape after recurrence. I can simply click promote. It's going to move this logic app up into the front of the line. Simply hit save. And now this is going to be the prominent executable version of that logic app. So this is pretty cool if you do go into logic app. Obviously your logic apps will be much more complex than this. And if you do want to revert back to an older version, that's all saved for you here when using your designer in the portal for your development. Let's go back to our first look logic app, go back to overview. And you can see here this logic app has ran several times. We set up the recurrence to run, and you'll see here multiple executions. If I do want to dive into any of these executions of the logic app, you just click on it. You'll see your trigger at the top, and I can simply click on that, and I'll actually see, if there was more data in here, you would see the actual inputs and outputs of this call. So if there was an HTTP trigger, for example, you would see the request coming into this trigger and then the response coming out of that trigger in terms of reformatting of the data. So you have input and output of each of these triggers and actions as you go through here. So this can be very useful when debugging and troubleshooting components. Hello, my name is Stephen Thomas, and this is another video in my series, Azure Integration Services and Hybrid Options. In this video, we're going to talk about Azure Logic Apps and talk about the differences between consumption and standard edition of the Logic Apps. Now, it can be confusing that there are two different types of Logic Apps. The consumption version of Logic Apps came out around 7 years ago, while the standard edition of Logic Apps came out about 2 or 3 years ago. Now, they're very different under the hood in the way that they run, but there's a lot of things that are very similar, like the designer is a very similar experience, yet they're different designers. So it can be confusing kind of look at what's the difference and where you should use consumption versus standard. Now, I've tried to explain this to folks in the past that are very new to Logic Apps. 4 or 5 times in the past, I've given this similar type of talk. The very first group, I would say, was probably more confused at the end of my talk than at the beginning. So hopefully by now I've got it a little more perfected. In addition to talking about the standard versus consumption, we also need to talk about the pricing details between the two, because the pricing is going to matter in terms of which direction you might lean towards in terms of building your logic apps. For all pricing details, of course, always check out the Microsoft documentation because pricing can change over time. With that, yes, it can be confusing, but I'm going to try to break it down and make it a little more understandable. So let's get started diving into consumption versus standard. I've thought long and hard about a way to try to compare and contrast consumption versus standard, try to put it in a way that's more relatable to folks. So I've come up with this analogy, and you'll have to let me know what you think of this, is consumption is a lot like a cat. So we have cats, we like cats, they're our pets in our house, they take care of themselves a lot, they're kind of low maintenance, so we like cats. But then we think of a standard edition logic app, and they're a little more like a dog. So we like dogs in our house, we have dogs as pets, and cats and dogs are both pets, and they both bring us joy in our life, and we like to have them. But that's how we get to a cat like consumption logic apps and a dog like standard. So why am I using this analogy? So consumption logic apps, much like a cat, are very easy. There's not a lot of thought that needs to go into how we take care of the cat on a daily basis. We bring the cat into our house, give the cat a litter box, give them some food. We don't have to take them on walks. We don't have to take them outside. Very easy experience to take care of a cat. And all in all, they're low maintenance. I don't have to really worry about what that cat's doing in a day. Most of the time, cats aren't out getting into trouble. Can be rest assured that my cat's going to be in good hands throughout the day. So the consumption edition logic apps is very much similar to an experience of having a cat around the house. Now we think about having a dog around the house, and it's a much more challenging experience. A lot more thought has to go into the day of a dog's life. So it's much more work. I think everyone would agree a dog is much more work than a cat, just like a standard edition logic app could be a lot more work than consumption. In addition to introducing a dog to your house, there's a lot more to get set up. So you have to have a dog bed, you have to have a leash, you have to have a strategy to take them outside, and then when it's raining, you have to account for that. Just like standard edition logic apps. You have to plan for how many logic apps are going to be in your environment, how are you going to break those up in your app service plans, how you want to structure resources inside logic apps because they can have multiple workflows. So it's a lot harder to set up and take care of than a consumption logic app. So at the end of the day, what does it really mean with consumption and standard? Well, they can all run together. There's no reason you need to be all consumption or you need to be all standard. You can definitely have a mix that involves all types of logic apps and just understand where you'd want to use one over another given your specific business scenario. So let's talk about a little bit more about the hosting options and where these things run at and why consumption is going to be like a cat and easier to take care of. So consumption logic apps, they're going to be all Azure hosted. So they're all going to be Microsoft managed. We don't have to worry about resource contention between our own logic apps. So there's no hosting needed with this. It's also a nice pay per use model. So it's a serverless model. So if our logic app sits there all month, runs only a couple times, we're only charged a few fractions of a penny for that execution. Now, with that, you are in a multi-tenant Azure hosted environment. So your logic apps could be running next to a noisy neighbor that's consuming more resources. So that's something you'll definitely want to keep in the back of your mind. But they are going to be fully supported and managed by Azure and the Microsoft team. So we don't have to worry about scaling up and scaling down with our consumption logic apps. There also is no support for virtual networks with consumption logic apps. So if you need to use that in your solution and you have an express route set up, you need to have all your components on the same network, that you would want to look at moving away from consumption. Now, that doesn't mean consumption can't access on-premise resources. It still can using things like the on-premises data gateway. It just means it can't be directly on that same network. Now, there used to be another hosting option for consumption, but I'll just mention it here. It was the integration services environment, also called the ICE environment. This was a fixed fee unit of work, but it's been retired as of August 31st, 2024. You can't even create new instances of this any longer. So just know there was an option here, but it's no longer available. So quickly, let's talk about pricing. As I mentioned, consumption is serverless, so it's pay per execution. You actually get your first 4,000 actions free, which is a plus. And you can see here it's a very small amount of money per execution. You do pay more for connectors than you do for actions inside your Logic app. And then there are some few 8 or so enterprise connectors where you do pay even more than that for those. These are small numbers, and I did some math. If you ran 3,500 actions and 500 connectors per minute per month, your bill would be $6,500. Now, that's an intense amount of processing there. One of my first clients that I set up Logic apps, their bill is $35 a month, and that does all of their EDI billing and processing for their whole month for $35. So you can see that's a very good price point and entry into a Logic app-based solution. I did another price analysis, and I think it was 10,000 messages a day, and you had about 20 executions or 20 actions per Logic app. You're looking at about $180 a month. So keep that in mind when you're thinking about consumption. Yeah, it's pay per use, and it can be relatively inexpensive, even with some high message load. So how do we host our standard edition Logic apps? Let's talk about that. So they're done a little bit differently. So they can be hosted in Azure, and Microsoft will maintain the environment for you. And they run in what's called an app service plan. So you can think of an app service plan kind of like a virtual machine. It's out there. It's kind of semi-isolated, but it does run on shared hardware. So your app service plan could be running next to other people's app service plans on the same equipment. So you want to keep that in mind. You still could have the noisy neighbor scenario. Data has to stay within the same region with an app service plan. So you can't have an app service plan that has Logic apps for multiple regions in it. It all has to be within the same region. Your pricing that you pay for your app service plan is going to be based on the hosting plan that you select. Now, for Logic apps, we currently have 3 versions of the hosting plan. We'll take a look at it in just a moment. But the plus here is your app service plans do have support for virtual networks, which is a big plus. There's also an option to have a more isolated environment called an app service environment. And there's several versions of these. To be supported with Logic App Standard, you have to be on v3 of the app service environment. And these are going to be single tenant and isolated environments, which is good. But for these, you must use a virtual network. Your app service environment has to be set up as specified on a virtual network. So all in all, you get much better network control in terms of integrating your app service environments with your on-premises resources. This would generally be used along with ExpressRoute, so where you have your on-premises data center connected with your Azure resources using these app service environments and your express routes and setting that up. So it's a much more advanced scenario. So a little bit more about standard. Also has Kubernetes in preview. These would be using pre-provisioned clusters, is designed to run in the Azure Kubernetes services environment. And they're working on getting it all Arc enabled for on-premise deployments as well. And if you wish, you could even run these on other cloud providers, which was something one of my clients was looking at. And with Standard Edition, you also have that option to run it in your own data center. You could run and host the Logic app environment on a server and then maintain all that. It'd be just very similar to running BizTalk server on premise. You're gonna be responsible for all of that hardware. I, for one, like to be out of the hardware game, so anything Microsoft hosted, I tend to go that route. So what's the pricing on standard? So this is going to be for the standard app service plans. These would be what we would build our components against in the Azure portal, for example. They have a monthly rate of between $175 a month and $700 a month. Now, with this, there's also other charges such as storage transaction costs, and then there's still the cost to those managed connectors. So the standard edition Logic apps have the ability to have built-in connectors. So there's a subset of connectors that run in process essentially with that standard edition Logic app. So those all run self-contained. So if you were running your Logic app locally, for example, there'd be no call anywhere outside of your environment for those connectors. Now, a lot of connectors are Microsoft managed connectors, and those, no matter where you run your Logic app, if you call that connector, it will make a call to the Microsoft hosted API connector and create that connection and make that call for you. So there is still the managed connector cost associated with that. That's the same if you're running in Microsoft itself in an app service plan, or if you're running on premise in your own Visual Studio instance or in your VS Code instance, it'd still be there. There is the plus side here with standard is there's no integration account needed if you want to do maps, schemas, and use .NET assemblies. So this is definitely a huge plus to introduce these into consumption. There's a substantial price hit for that. And the only catch here is, that's why I have the asterisks, is they're compartmentalized at the workflow level, and we'll talk about the workflow in just a moment. At the workflow level, which generally contains about 10 or 15 Logic apps inside there. So if you have schema and maps that need to be shared across many Logic apps, for example, you might have to multiply deploy those to multiple workflows, or have a third-party service that manages it, or still use your integration account if you go that route. Real quick, the ASE v3 environment. These are pretty standard pricing. These can be used for other things besides Logic apps as well. Their monthly prices are between $240 and about $1,000 a month. There is other costs with this, like you do require your virtual network. And for comparison, that retired ISE environment is almost $5,000 cheaper per month for this ASE environment as compared to the ICE environment. So what are my recommendations? What should you do if you're new to Logic apps and want to get started? Well, here's what I would suggest. There's no reason a solution you build for an enterprise client can't be both. You can definitely have a mix of consumption and standard. They're separate. You can't cross deploy. You can't build it in consumption and then just automatically move it to standard. They do have a converter tool to help with some of that, but they're different workflow definitions. So you can have both of them coincide and have them do different tasks. So I always recommend, especially new developers wanting to just jump in and work with Logic apps, to start with consumption. It's going to be your easiest. Even if you build out an enterprise or a business grade scenario, build it out in consumption. Most of the time it's going to be pretty straightforward to move it over to standard. And there is that converter tool if you wanted some help. But just open up 2 windows and open up 2 designers, and once you've worked out the details in consumption, can move it to standard. But if you wanted to have a long-term bet, you're all in on Logic apps, you're going to essentially, like if you were migrating a BizTalk environment to Logic apps, I would bet more long-term, be more focused on standard edition. Consumption and standard, I think, will always be there. There'll always be kind of the options between the two. Newer features and things tend to come to standard first. So keep that in mind as you build out solutions, especially if they're going to be full, like multi-year BizTalk migrations. I would tend to focus more on standard. So there are lots of factors that come into play. If you have a lot of workflows that don't run very often, that might be a strong contender for consumption. If your network policy enforces that all components must be on your same network, connected via express route, via a virtual network, well, then you're going to have to go to that standard route. And if things don't match between the two, you'll have to come up with a solution that does work for you. Features and connectors are not always in sync. So this was a much larger problem 6 months to a year ago, where consumption had a rich set of connectors and they were porting them over. There's some differences in some of the connectors when you move them over to standard, especially when you talk about the built-in connectors that run in process with standard as compared to standard and Microsoft managed connectors where you have to make a call out. So there was some contention around that. It's gotten a lot better now. So parity between the two is much better. There's still things that come out and get you kind of new features in standard, like you can now run essentially functions in process with your standard edition Logic app. It's like a .NET method. It's like in BizTalk where you had helper.NET classes in your orchestration. Now you can have that same thing in standard edition. It's going to run and be hosted inside that same process. That concept doesn't really exist for consumption Logic apps because you're in the serverless environment. So with standard, you do have some additional kind of bells and whistles that you can work with there. And if you're going to be all in and you're going to do like a big BizTalk migration, I would definitely look at the ASE v3, setting up your express route, getting your network, fully connected and integrated between your on-premises data center and your Azure environment. So when it comes to building out solutions, here's just a picture I copy and pasted from the Microsoft help documentation. The differences between the single tenant and a multi-tenant environment. Microsoft classifies standard edition as single tenant environment because you have the ability to very easily be isolated in a single tenant environment. Multi-tenant is going to be your consumption logic apps. And the way you build solutions is a little different. So with standard edition, you have the Azure portal, of course, and then you have VS Code. It's going to be a supported development tool to do local development of your logic apps. You still will need internet connection because it's query out quite frequently to get a list of connectors and stuff like that. Your multi-tenant, your consumption logic apps, you can build them in the portal like you could standard, but it also does support VS Code and some older versions of Visual Studio as well. It has a plugin for that. And you can also do other ways to deploy your scripts, as you can see here. So your designing and development would be a little bit different between the two. Okay, so with that, let's jump in and let's see a quick demo of creating both a consumption logic app and a standard edition logic app. Okay, I've now jumped over to a virtual machine that has already logged me into the Azure portal. We're just going to go up here to Logic Apps, and I'm going to click Add, and going to leave my subscription the same. I think I already created a resource group earlier, a live demo. We'll give this a name, Demo Consumption 0505 to make sure it's unique. It's a workflow. I'm going to leave it in East US, and I'm going to switch it to consumption-based logic app. And with that, you can see some of the other options here went away. I can select do tags where I can set like a cost center and go to review and create and go create, and it's going to go ahead and create my logic app for me. It takes just a few moments to create this logic app. And I'm just going to jump into the resource really quick and show you that here you have your logic app. I can jump right into the designer at this point and start building actual physical components to this logic app. So in this case, this logic app is going to be my workflow and is going to do the work for me. You take a quick look over here on the left. This is your core settings that you have for this logic app. And I'll go through them in more detail in some of the other videos. But just to know that this is where you would come and control all these settings at the scope of just this logic app. So let's see what it's like to create a standard edition logic app, because the experience is going to be very different, or a little different, I should say. I'm going to keep the same subscription and live logic app standard. And going to keep it at workflow. I'm going to leave it at East US now for just a moment. Keep this at standard. And then you see now that I have standard still selected, I have to select a Windows plan. I have to select an app service plan for this to run in. And then it says new because no plans exist. And then I can select the size, the pricing options of this plan. And you can see here it gives you an estimate of what that's going to cost per month. In this case, I'm going to switch my region to Central US. And in this case, I have an existing app service plan that it pre-populated here for us. If you remember, the app service plan resources can't span multiple regions, multiple data centers. So that's why you have to select the data center that your app service plan resides in, and then you're able to select that app service plan. So if you're struggling, can't find your app service plan, was sure you made it, go check what region you created that app service plan in. So I'm going to leave this as default here. Zone redundancy, just leave that there. And now you jump over and we have a lot more things we have to think about. Just like bringing that dog into our house, we have to think about the toys for it to play with and all that, dog bed, all the good stuff. Here we have storage. So storage is going to be where our physical logic app files are going to reside. So we have to set up a storage account. We can just leave the defaults and it's going to create a new one for you. And here we have the ability to set up some network settings for this. So you can enable public access, enable network injection if you would like. So it does have some virtual network support here, but we'll leave that the same. Come over here, you can select application insights right here at the time of creation that you can assign to this. If you wished, we'll just leave that for now. I will set my cost center. And review and create. Now this will also take just a moment to create, and we'll see it over here on the right when that is complete. And it's going to go ahead and provision this. We'll take it just a moment. Okay, that's completed. So now we can click go to our resource. And don't forget, if you missed this status bar on the right, they're all up here where the bell icon is. So I'm going to go to that resource. And what we see here is this has a different look and feel as compared to the consumption logic app. So in standard edition world, you can see up here it says logic app standard. The logic app itself is a container for other workflows. Container is a poor choice of words there, not to be confused with other containers. It's more like a site. So I think of it kind of as IIS, it's a website in IIS, where then you can have multiple files, multiple HTML files in there. Well, you can have multiple workflows inside of a single logic app standard. And those are, you'll see over here. So if we look at the left side over here, we see it's very different than what we saw in consumption. And we have our workflows, connections, and parameters. And then down here, remember I mentioned we can deploy our schemas, maps, and assemblies directly to standard edition. Well, we can do that here. We can upload schemas and maps right here if we wished. Down here, some additional settings, scale up, scale down. That's one you want to look at here. So now I have to be concerned with the resourcing of this app service plan. So as with consumption, we didn't see these kinds of options of setting scale up and scale down because it's going to take care of that for us. Now we have to be more mindful, more understanding of the workloads that we're going to deploy into this logic app standard edition component there. App service plan, we can jump into our app service plan and adjust those settings at the plan level, see resource allocations and all sorts of stuff like that, and even change that app service plan if we need. Some other things down here about some APIM management, some monitoring tools, automation, all in all, a lot more options than what we saw in consumption-based logic apps. So a lot more stuff we have to worry about. Let's go ahead and create an actual workflow here. So I'm going to jump into workflows. And it says we have no workflows. I can click add. And here I was just going to say live demo. And as compared to what we saw with consumption, we have two options here. We can create a stateful logic app or we can create a stateless logic app. Stateless logic apps don't give you the ability to walk through action by action and see all the inputs and outputs of that. Stateful will give you that experience just like you get in consumption. Now with stateless, you can come in and turn on what's called a debugging mode, and then you're going to be able to get that state. So keep that in mind. Stateless isn't always better. There can sometimes be restrictions in different connectors that you can or cannot call in a stateless experience. So you want to kind of keep that in mind. So it definitely fits a need when you need a low latency scenario. There's also been some complaints around the fact that it's no logging at all, so you don't even know if it gets executed. So it can be challenging to work with in a stateless environment. You'd have to go in and turn on that debugging mode to start seeing if anything is even happening. So for now, let's click stateful, and I'll click create. And that's going to create pretty quickly here, and I can dive into here. And if you are experienced with the designer, I'll dive into here. This designer is a little bit different. You'll see there's a very different look and feel between the designers. This has, I guess I'd call it a more modern look, kind of a, I don't know, cooler look. Definitely is some differences, and things are, I feel, laid out a little better here. You have the ability to add the trigger. Trigger is going to be your entry point into that logic app. But here you have this ability to set the runtime. So I mentioned a little bit about things that run in process versus things that make called into Microsoft managed components. You could select those here. And if I select an app, these are going to be all the components that run inside of this logic app directly. So things like things that you would think would run in process, generally do. Things like an HTTP request, schedule to kick off that logic app and stuff like that. We'll just click schedule for now and select that to leave us our time interval. And then we can go ahead and select actions underneath that. And you have the same experience here. I could say shared in this case, and these are going to be all the Microsoft managed connectors. The one that if you were running this locally or running it in a different cloud provider, you would still be charged those small fractions of a cent for calls into these Microsoft managed, Microsoft hosted components. And it does call them shared so that you do realize that they're all multiple tenants calling these at the same time. These aren't a dedicated environment like you get with the logic apps. These aren't dedicated API connections for you. The in-app ones are, of course. So you have a lot of options here. Like I said, there's hundreds and hundreds of connectors, ever-growing list all the time. So now once I'm done, I can click save on this logic app, and it's just going to save this logic app, and now it's going to execute every 3 minutes. Of course, this one doesn't do anything for us, but we could add actions down here and have this perform work tasks for us. So this was just intended to give you a quick overview of how you create consumption and standard edition logic apps and the things to kind of think about when creating one versus the other. Hello, my name is Stephen Thomas, and this is a video in my series about Azure integration services and hybrid options. In this video, we're going to talk about Azure Logic App connectors. As we get started talking about connectors, let's first start by talking about triggers. Triggers are exactly what they sound like. They're essentially the entry point to a logic app. You have triggers that start both consumption and standard edition logic apps. And when the trigger fires, it will run all the actions underneath the trigger if there is data found for that trigger. So it does exactly what it sounds like. Now, there's a couple different types of triggers that we should know about. We have recurrence triggers, which is essentially a way to schedule a logic app to run on a set interval. We have polling triggers, where the logic app will, at a periodic interval, go out and look for data to consume. So this could be like a SQL trigger that calls out to a stored procedure to look if new records are available, or like checking for new data in a service bus queue, something like that. Now, most polling triggers, we have the ability to adjust the time interval on that polling interval. So want to keep that in mind, especially if you're using consumption edition, because you are charged for each time that trigger does execute. So if you set it for like 5 seconds, there could be different cost implications as compared to setting it to 5 minutes, for example. There's also event-based triggers. These are triggers that happen in reacting to something that happens in the Azure environment. So you could set up an event trigger for data being added to a storage account, for example, or something like that. And the last type of trigger is going to be HTTP triggers. These are triggers that are going to be activated as response to an HTTP request starting off your logic app. Now, as we dive into connectors, let's talk about the two different main types of connectors. Inside each of these connectors, you do have a collection of triggers and actions. So each connector is essentially a component around triggers and actions for that connector. Now, the two core types of connectors is going to be built-in connectors, and then we're going to have managed connectors. These are going to be Microsoft managed connectors that we talk about. Let's dive a little bit more into built-in connectors. So our built-in connectors are going to actually run in the runtime itself. So actually run with our workflow side by side. We used to have an option for built-in connectors for consumption logic apps, not anymore. That ICE environment has went away. The only type of built-in connectors we have now are going to be the connectors for standard edition logic apps. Those will allow us to run side by side with our workflow, going to be a little bit more performant, allows us to take the standard edition logic apps anywhere we want. We can run it locally, run it in another cloud provider. And as long as we're using these built-in connectors, we're going to be okay because everything's going to run in process with that workflow. Now we have managed connectors. These are going to be Microsoft managed connectors. The vast majority of connectors are going to be managed connectors. That means Microsoft takes care of everything for us. They do provide us an API endpoint that we interact with, authentication mechanism, and then Microsoft's going to take care of connecting to that backend third party for us and kind of broker that communication for us. These are very similar to what we think of as adapters in BizTalk, as where in BizTalk they were kind of full managed devices. Now, you can still call managed connectors even if you're running standard edition logic apps on premise. Just make sure that you can still access the internet so it can reach out and make those calls to that managed connector. Now let's talk a little bit more about API connectors. So while we were talking about kind of connectors in general, Microsoft has implemented their connectors as what they call API connectors. And these API connectors are just essentially a wrapper around other APIs for the most part. So you have a API connector around ServiceNow, for example. So they've wrapped ServiceNow connectors around their own API connector, API facade to kind of give you a consistent interface for interacting from your Microsoft Azure components to your third parties, which is nice. Logic apps and Power Platforms will share the same connectors for the most part. The same ecosystem of connectors is going to be available for both, which is good. There's hundreds and hundreds, if not thousands, of connectors out there. A lot of them will be in preview, where they're going to be kind of subject to change, I guess, in the preview mode. You also have third-party connectors, which are a little bit beyond Microsoft managed. They're going to be developed and maintained by a third party, but they are still going to run most part in the Azure data centers. And then you have some other connectors that are premium and enterprise grade connectors. So your SAP connector, IBM connectors, some connectors like that, those are going to be considered premium, and they do have additional cost for those connectors. If they don't have a connector for an API you need to interact with, you can create your own custom connectors, custom API connectors. Very easy to do, very straightforward. And what this does is it gives you, again, that consistent implementation path for that connector that you can then share across everyone in your enterprise working with logic apps. They can all interact consistently. So think about that as your needs arise for those types of non-supported destinations. And you can get the full list of all the connectors here, constantly changing, ever growing, a very rich set of connectors available. Just to give you an idea, here's a view from a couple months ago of all the connectors that were available. You're not supposed to be able to read this, just to give you an idea that there is a lot of Microsoft provided connectors out there. So it's very easy to interact quickly with many of these third parties. Okay, so let's dive in a little bit more. What about API connections? So what is an API connection? And we're going to talk specifically right now about Microsoft managed API connections. So basically an API connection, you can think of it as an instance of a connector. So you have like a SQL connector, for example, and then when you go to implement it, you're going to create an API connection of the type of that connector in the case of SQL. Then inside there, you're going to have your triggers and actions all related to SQL that you can use. So connections are going to be first-class Azure artifacts, which means they're going to be fully accessible through the portal. And while they feel like they belong to a logic app and they're generally created inside of a logic app, they very much are not a sole property of that logic app. So they are first-class Azure artifacts. They live at the resource group level. So again, they can be shared across many logic apps inside that resource group. And they can be independently managed. So you can go into API connectors inside of the portal and make changes to these connectors independent of your logic apps. They also, as I mentioned, can be shared across logic apps. So you create a SQL connector in one consumption logic app. It can be used in multiple consumption logic apps as well. You can create them via PowerShell or via the designer. A lot of projects will create like a API connector manager who's kind of responsible for seeing what connectors you're going to use, creating the API connections for those connectors, and kind of maintaining them across the project. That's otherwise you can get into people are creating all kinds of connectors all over the place, and that can cause some issues. We can also, as I said, create it via PowerShell in most cases. There also are some that basically have to be created in the designer due to the authentication mechanisms that they use. So you have to view each connector. It doesn't do very good about explaining, the best way to create it or deploy it. But a lot of stuff's online that'll help you out with deploying your API connections. And as I mentioned, without having like a connection master on the project, it's very easy to get into the scenario where you have many API connections using the same connector, just because many different developers are creating their own API connections. So if you get in this, you look through your Azure portal, you see connection 1, 2, 3, then you know you probably have a problem. We need to have a little more managed control over creating your API connections. And now we have API connections that live in app. These are ones that run inside your standard edition logic apps. These are also going to be instances of our API connector, just like we saw with Microsoft Managed. And these are going to be scoped a little bit differently. So the Microsoft Managed, remember, are scoped to the resource group level. These are going to be scoped at the standard edition logic app level. And remember, although standard edition logic app can have multiple workflows inside of that logic app. So you can have 10, 20, maybe more workflows, and these would all share the same in-app connectors that are created at that core standard edition logic app level. And with that, inside of our standard edition, we'll see that there's 3 different types of connectors that we'll see. We'll see our API connections. These are going to be our Microsoft Managed. These will show up in our Azure portal under API connections. We're going to have our service provider connections. These are going to be our in-app connections. These are going to be things only that live at the standard edition logic app level. Then we're going to have our function connections, which is just like it sounds, connections to any functions that we're calling in Azure. So let's take a look at how we'd go about implementing this. Connectors and hosting going to be a little different between consumption and standard edition. In consumption, you're going to have a search box. You can search for the type of connectors you're looking for, and then you'll get a set of triggers and actions that you can implement. Same is true with standard, except now you have the ability to select the runtime. So this is, are you going to run in app, which is going to be in process? Are you going to be shared, which is going to be Microsoft managed? Or are you going to have a custom, which is going to be one of your custom third parties that you're going to create, a custom connector? So with standard, you have a little bit more thought to put into this. Some things will be able to run both in process and Microsoft managed, things like the service bus, for example. And there's also some limitations on whether you're running a stateful or stateless standard edition logic app. You'll have the selection of connectors will be a little bit different between the two. All this information is kind of embedded in the Microsoft Learning documentation. When you do a search for connectors, it'll list connector by connector and tell you kind of where it can run and whether it's Microsoft managed or can be run in process. So all that data is there. You just have to make sure to look it up per connector. Okay, so let's dive into a demo about working with API connections. Now let's jump over to the Azure portal. I've already logged in and pre-created a consumption-based logic app. In this logic app, I've just created a recurrence trigger, and now let's go ahead and add a connector. I'm going to go to New Step, and here we can see the available connectors to us. Now, I mentioned that everything here is going to be Microsoft managed. There are, in fact, some built-in connectors. The built-in connectors here are going to be things like flow control and things that are core to running a workflow, some HTTP request response type of stuff. But in general, all your communication with the outside world to third parties is going to be done through Microsoft managed connectors. So for the purposes of this, I'm going to come back to For You. I'm going to go ahead here in the search and let's look for Outlook. And it'll take it just a moment. And here you can see the Office 365 connector. Let's go ahead and click this. And I want to go ahead and send an email. And send an email with options. Going to select this one. Going to sign in. And here's where I'm going to go about actually creating my instance of this connector. Going to go ahead and select an account. And you can see here it's pre-populated everything for me. It has my connection set up here. And I can go ahead and give it a to address. And it doesn't matter. And go ahead and save this logic app. We're just interested in looking at the API connections for now, so we won't actually do anything with this. So with that, I've created this connection. If I do want to change it, if I had more than one already in this resource group, I could click Change Connection. And here you would see all available connections that were to Outlook that I could select here. I'm going to cancel this. We can come over here under API connections, and here we can see our Office 365 connection that we have created. Now, I mentioned that these are Azure First Class citizens. So under API connections here, this lists all my API connections in my whole Azure subscription. I'm going to do a refresh. I'm going to go ahead and whittle this down to just this resource group. It's a live demo. Click apply. And here you can see that API connection that I created. I can click on this and I could go to properties, view some of the properties here. Now, if I wanted to make adjustments to this, I could click on edit API connections. And here I could edit this API connection. So if this was a SQL connection string, for example, I could edit that here. Things like database name, username, password, all that would be accessible here. I could re-authenticate if I wanted, and all that would be done right here. Now, this is at the resource group level. So if this API connection was used in multiple logic apps, I would be changing that connection properties for every logic app that consumes this API connection. So particularly if you're working with SQL Server databases, I've seen issues where developers will come in here, change a SQL Server database to point to their local database, for example, and then everybody in the whole resource group will now be pointing to their local database. So that's kind of another good reason why it's good to have one central resource that's available to manage and maintain these API connections for you. So with that, that kind of shows you quickly how to use this in a consumption-based logic app. So let's see what this looks like in standard edition. So I've now jumped over to a standard edition logic app, and I've just went ahead and pre-created 2 connections here for us. Let's click on the plus icon and see what our experience looks like here. I'm going to go add an action. And it's very similar to what we saw in consumption-based logic apps, except this time, as we saw in our slides, we have both in-app and shared, where I can select different types of runtime. Here, let's do a search for Service Bus. And as I mentioned, you will sometimes see both in-app and Microsoft managed connectors here. So this in-app means it's going to run in process with your Logic app. The one without the tag would be a Microsoft managed edition. Now there's different times you'd want to use one versus another. So it all kind of depends on where you're going to run and host your standard edition Logic apps. So I've already pre-created 2 items here. My insert row into a SQL Server database. This again has my connection information here. This is going to be an in-app call. So this running in process. And I have my send an email, just like we saw before. This is going to be our Microsoft managed connection here. So let's go ahead and see what this looks like. I'm going to go back to the root of my standard edition Logic app. Remember, they can have multiple workflows in that Logic app. And here under connections, this is where I'll see my different types of connections that I've created for this, for every workflow inside of the standard edition Logic app. So I do have my Outlook connection here and my display name. Then under service provider connections, here are my in-app connectors that I have created. Now this API connection we see here, this will show up under my API connections, under my resource group, because this is going to be first class citizen to Azure running in that resource group. So this was a quick overview here of kind of how to set up and use connectors and API connections inside of your Logic apps. And let's jump back to the slides. Hello, my name is Stephen Thomas, and this is another video out of my series on Azure Integration Services and Hybrid Options. In this video, today we're going to focus on some of the core features that make up Azure Logic Apps. These are features that everybody should know when you get started working with Logic Apps. Let's jump right in, and the first core feature I'd like to talk about is retry policies. Retry policies are actually set and configured per action inside your Logic app. So you can have different retry policies based on what that action is actually doing. You get automatic retries whenever there is a 408, a 429, any 500, or any other type of connectivity exception. In these cases, your action is going to automatically retry according to your retry policy set on that action. Of these, you'll probably run into the 429 retry. This happens when you call a Microsoft connector and it gets back a rate limit exception. In this case, you've made too many calls within that rate limit, and it'll wait for the configured amount of time and retry. You define the retry policy in ISO 8601 format. Here's what it looks like to set that retry policy on your action. Every action has a default retry policy. I believe it's set as incremental to go every 15 seconds and then goes up from there. You can define your retry policy as none, exponential, or have a fixed retry policy. The next feature that's very important is the run after. Run after can also be configured per action in your Logic app. You can use run action to modify the flow control inside your Logic app. Run after can be used to also configure a try catch setup inside your Logic app, and we'll see this when we get to our demo. The 4 things you can configure for run after is successful, has timed out, is skipped, or has failed. There are different times you would set these on different actions based on what you want your logic to accomplish. Next is testing with static results. Sometimes you may be calling a API connector, but you don't want to actually make that connection. You want to simulate the results, and that's very easy to do. You can go to that action, go to the testing tab, and you can configure static results. Something else that's very useful and powerful inside Logic apps is functions. Functions are small units of what it calls like function code that allows you to do simple tasks such as string manipulation, date manipulation, and other things like that. There are lots of built-in functions, I'd say over 100 or so, to accomplish a lot of things in your Logic apps. Some of the things I've used functions for is casting in and out of base 64 and other casting needs, such as casting in and out of XML and in and out of JSON format. You can also use it for string manipulation, collection manipulation, logical functions, and a whole host of different things. The next core feature is the ability to define a JSON schema on some triggers, such as the HTTP request trigger allows you to define a JSON schema for the inbound message. This way, it will parse that inbound message and make all those properties available for you inside IntelliSense, just like it was another Logic app property. This can be very useful. Once you have defined that schema, you get full access to all of these properties. Content type. Content type is also important inside Logic apps, especially when making inbound HTTP calls. Logic apps has native support for many different types of content types, such as XML and JSON. There's a lot of times you have to cast and convert back and forth between different content types because some actions will natively support certain content types, such as some will want to be a JSON content type if you're dealing with JSON actions, for example. Debatching is also supported inside of Logic apps. You can set a property called split on and then define either the JSON or the XML expression you want to use to debatch that inbound request. So if you have a message that contains multiple people inside that message, for example, you could debatch that message at the person level and it'll create a new independent Logic app for each of those people inside that message. Now, split on it sometimes is exposed in the designer, depending on if you're using standard versus consumption. And there's some other nuances with split on, but in general, it's a very good property, very good feature that's there that you can use. There's also batching and debatching support inside of integration accounts. This is a very legacy feature that I don't see leveraged very often. Here's a few quick other tips that I want to point out. Make sure when you add a new action to your designer surface that you rename that action as soon as you add it. If you add a dependent action underneath it, it won't let you rename that action. So go ahead and rename it as soon as you add it. And once you add an action, make sure you fully configure it before you move on. Back in BizTalk world, I used to add a bunch of shapes to a orchestration designer, and then I would sometimes print out that shape, I'd save it, and then kind of work through it on paper. When you add an action to a Logic app, you're not able to save that Logic app until you fully configure that action. So make sure when you add that action, you fully configure it. You want to make sure you save often and make sure you always save before you switch over to the JSON code view. For each inside Logic apps kind of behaves a little bit differently than you may believe. It can be configured to actually run sequential, which is a traditional thinking for each is one at a time, or it can be also configured to run in parallel. So you could run 20 instances of your for each loop at a time if you may wish. So make sure you have that set based on your business needs. You also want to make sure to avoid using more than one Microsoft account, and also make sure your Microsoft account is a work or school account. Years and years ago, I set everything up with my Hotmail, and I continue to run into issues using that Hotmail account. Now with that, let's jump into a demo. We're going to take a look at retry policies, run after, functions, and JSON schemas. We're going to jump into the Chrome browser and take a look at a demo. I've already logged into my Azure account, and I've already went ahead and created a couple standard edition logic apps. In this logic app, we're going to simply receive an HTTP request, initialize a variable, do some stuff in our scope try block. When we get an error, come down here to a catch block, set a response, and then simply return that response. This response in the catch block simply says catch. This response here simply says that it was successful. So let's take a look at what we have set up here. First, we want to look at how we would set up our retry policies. In this case, this HTTP request is going to create a 404 error. In here, we could come in and go under settings and come down and look at our retry policy. This is actually going to follow our default retry policy, but if you remember from the slides, 404 will not trigger an automatic retry, and we'll change this to something else later to see what it looks like when it does. And I can select this drop down, and I can select different options here. I can select a fixed interval and specify how many times and the seconds that seconds or minutes between those calls that I want to have in that fixed interval. For now, we'll go ahead and leave that at default. And let's go ahead and just run this and see what happens. And before we run this, let's see how I've set up the scope catch shape. This is simply just a scope shape that I've added. When you click on this, you go under settings, and they've now exposed the run after property very nicely here. You can have multiple items configured in your run after. You would simply select actions. You can select any other actions here that you want to have tied to this scope shape. I just have one, and that's my try block. And in here, I want to have, I don't care if it's successful, I don't want to run it in that case. I want to run it if it's timed out, skipped, or has failed. So that's the criteria for running this scope shape. In that case, it'll run all those actions that are contained in that scope shape. So let's jump over here to Postman real quick. I'm going to go ahead and make this request. It's going to make that call in and returns catch. So that means it's been hit inside of our catch block. So let's take a look at what that looks like. So we're going to jump over to Overview and take a look at our last successful run that was right here. Now, it did actually give an error, but since we handled that error here, it showed this logic app as ran as successful. So make sure you keep that in mind, that because the logic app says it ran successful, if you have run after logic configured, it may not show up as an error run for that scenario. So in this case, sure enough, we got our 404. It ran 0 seconds and then jumped down here to our catch block and returned our response. So let's jump in and modify this process. Instead of 404, let's change this to a 429, should be like the rate limit. And go ahead and save this. And let's go ahead and run this again. And I've went ahead and ran this again, and you can see it's sending the request and it's waiting for the response to come back. It's not coming back as quickly as we saw before. So let's go ahead and jump into this running logic app and see what's going on. Going to go back up here and go to Overview. And you can see here that we have a running instance of the logic app. And I'll dive back in there again and show you that it's still spinning on this error 429. That's because it has the default retry policy configured. So it's going to take it about a minute and a half or so. Then it'll eventually throw an error on this process and go ahead and run down to our catch block. In that amount of time, our request may or may not have timed out that we've made to this initial logic app. So this is really where you'd want to make sure you set your retry policies to correspond with the type of trigger. If it's a request response trigger or not, you might want to make sure you modify those retry policies. So now let's jump back into our designer and let's take another look at some functions that we can set up. When we're inside our designer, I'm just going to click on my compose shape, and you go over here on the left and you see this FX. And this is how you get access to all your functions. We have functions and dynamic content, which is in this same selection window, and you can click see more over here on the right, and it's going to show you all the different types of functions available to you. Collection functions definitely used a lot, and a logical conversion, math functions, date time functions, of course, reference functions, workflow functions, and URI parsing functions, and some additional manipulation functions. So there's a lot of different functions you have here. So a lot of different things in here to do a lot of complex manipulation of data. Very useful in processing results they return from one of your other actions up above. So with that, let's jump over to one of our other workflows. This one I've created to show how we can assign a JSON schema on our inbound HTTP request. So I just have an HTTP request here, simple compose shape that really does nothing right now. And what I want to do is have a response. I'm going to add an action and add a response here. And I want to return the response from this compose shape. I'm going to go to my dynamic content. And in this compose shape, I have the pizza size is, and then it's blank. In this case, I want to define an HTTP schema here. I've already done that by simply using a sample payload. And I'm going to copy and paste in my sample payload from my Postman message that I'm working on over here. And you can see that. I click done. In doing so, when I go to my compose shape, I will now have the pizza size is. I can come over here to dynamic content, and I have all the IntelliSense for the parsed JSON schema right here, just like that. So that should return my pizza size. So I'm going to jump back over into Postman, but what I want to do is go into headers, and I want to turn off the fact that I want to pass in the application JSON content type. So I'm going to go ahead and run this. And you can see here I got my response, but it says the pizza size is blank. I'm going to go ahead and click on content type, run that again, and now it says the pizza size is small. So without specifying the content type, the logic app didn't know that it was JSON, didn't know how to parse that message. So once I specified that content type, I was able to come in and specify and get that piece from the JSON message. Oh, one last thing I wanted to point out, I'm going to jump back over to my retry policy, logic app, go back in the designer. And if I want to set those static results, let's say down here on the 429, I can go under testing. I can say enable static results. I'm going to say success. And I want to have output defined. And I want to say all okay. I'm going to go ahead and save that. So now if I was going to run this again via Postman, this time we would see it was successful. So in past results, we'd had an error there, either a 404 or 429. That the 429, remember, hit the retry policy. This time with the static results, went right through and came out successful. But you will note here that in that action, it does show this little science beaker bottle, I guess that is, to show you that you are using testing results there. So with that, this was a quick demo of some of the core Logic App features, and hopefully this sparks your interest and want to jump in and try Logic Apps yourself. Hello, my name is Stephen Thomas, and this is another video in my series on Azure Integration Services and Hybrid Options. In this short video, we're going to see how we can use BizTalk Server 2020 to call Logic Apps that we've created in the cloud. Let's first get started by talking a little about what support BizTalk 2020 has for Azure Logic Apps. BizTalk 2020 supports HTTP-triggered Logic Apps. BizTalk 2020 has a native adapter that you can use to set up and make these calls. This support is limited to one-way calls only, so anything that is request response will not be able to be called using this approach. Now, just because you can use the Logic App adapter to make a call into the Logic App, it doesn't mean it is always the best way to go about triggering a Logic App, or even the best way to communicate from on-premise to Azure in the first place. I'm a bigger fan of using Service Bus because it's more durable. So if that's an option and you're looking to bridge BizTalk 2020 to your Azure components, I would tend to lean towards the Service Bus if that makes sense to do so. That said, you can even have Logic Apps in Azure call back into your BizTalk server and actually execute things in your receive locations using the on-premises data gateway. Now, this is a super cool feature and something we're going to demo when we start when we talk about the on-premises data gateway. So let's take a look at how we'd set this up if we are going to use the Logic App Adapter inside of BizTalk 2020. You can simply copy and paste the HTTP URL into the adapter window there. Supports that just fine. And if you wanted something a little more dynamic and didn't want to mess with that, you can simply sign in to Azure using your non-personal account. So not a Hotmail account, it has to be a work or school account. And then you select your subscription, resource group, Logic App, and the trigger that you want to execute. So this is a nice way to make it kind of auto-configure things for you. So with that, let's jump into a super quick demo and seeing how BizTalk 2020 can call a Logic App in Azure. Now I've jumped over to our virtual machine that's running BizTalk 2020. I've pre-configured a couple send ports here, and let me just show you how I set them up. I'm not going to actually run them because it's not very exciting to actually see it execute, but you'll get the idea by seeing how we would set these up. The first one here is set up using the Logic App Adapter, and I can click Configure. And here I simply pasted in the URL that was given to me inside of my Logic App. If I didn't want to go that route, I could click Configure. And like I said, I could sign into Azure using a non-personal account and select everything here and it would auto-populate for me. In this case, I simply copy and pasted the URL. You can set binding information here and also define your outbound headers if you want to manipulate them right here when you make this call. And it's that simple to set up and make a call from BizTalk to an HTTP exposed consumption Logic App in Azure. I'm going to go back in here and let's take a look at how I did it in an alternate method. Here's a second send port. And in this case, I simply just used the HTTP adapter. This is just an old school adapter that came out when the very first release of BizTalk 2024 came out. So it's there for us. And I simply pasted in that URL just like I did in the other example. And here you have the ability to set some proxy information if you need to go through a proxy to make that outbound call. And I could define some authorization here, but the inbound call to your consumption Logic App that exposed is just going to be an anonymous call using that SID ID inside of your, essentially a token inside that HTTP request to make that call. So no authentication there. If you did want more richer authentication, you could look at using APIM, API management solution to add richer authentication and put that in front of your Logic App, for example. So with that, it's that simple to call into that Logic App. So either of these methods work. And if you're working with BizTalk 2020, you can communicate with your Logic Apps running in Azure. Of course, there's always room to migrate. So if you're looking at migrating your BizTalk solution into Azure, this can definitely be a bridge to help facilitate that. Hello, my name is Stephen Thomas, and this is another video in my series on Azure integration services and hybrid options. In this short video, we're going to take a quick look at Azure integration accounts. Let's get started with an overview of what integration accounts are. I'm going to get started by flat out saying they're not really as relevant as they once were. Logic Apps first came out 7 or 8 years ago, and integration accounts was one of the first core add-on features that was added with Logic Apps. And it served a great purpose back then. But now more of the support of integration accounts is being added directly into the Azure Logic Apps platform. Things like schema and maps are now directly available in Logic Apps Standard. So that makes the integration accounts a slightly less important than they were in the past. That said, integration accounts can work with both standard and consumption versions of Logic Apps. Integration accounts were really designed to add B2B support to your Logic Apps. This includes things like setting up trading partners, creating agreements, and doing connections via AS2. This was a lot of the things that was originally in BizTalk Server that was then ported into the cloud. These were at one point in something called BizTalk Services that was in Azure, and then that kind of ported into what is now integration accounts. As I've already mentioned up above, schemas, maps, and assemblies are now included out of the box with standard edition Logic Apps, as well as a lot of the integration connectors that we're going to see in a couple more slides. So what's kind of the history of integration accounts? They definitely started off on the wrong foot when they were first introduced about 7 years ago. So if you think back when Logic Apps consumption first came out, there was a huge push into the serverless model that you could run a whole bunch of logic apps and only pay for your consumption of those logic apps. If you ran very few logic apps, you paid just pennies. So that was a great model and got a lot of people excited about logic apps. Then they introduced integration accounts, which back 7 years ago was the only way essentially to do schemas and maps and your trading partners. So with that, they introduced a pricing model, which didn't necessarily jive with the serverless approach to logic apps. That pricing model is still in place today, and they came out with two different versions. They had a basic edition of integration accounts and a standard edition. Basic edition will run you around $300 a month and is really designed for people using the schemas and maps extensively or set up to do one trading partner. If you need anything more than that, you need to move to a standard edition logic app, which came in at a pretty hefty price tag of $1,000 a month. So with this said, I have heard talks that there's some updates and enhancements coming to integration accounts. So I wouldn't be surprised if in the near future we see that there's additional pricing options for our integration accounts. But for now, we have standard and basic. There also is, I should point out, a developer edition of integration accounts, which is now available. It wasn't 7 years ago. And that gives you the ability to test out these features and set up your schemas and maps for development purposes. So make sure you check that out. You are limited to one developer account per region per subscription. So make sure you understand that limitation. Integration account connectors. So again, to give you a little bit of history, 7 years ago, the only way to get access to these connectors was through an integration account and adding that integration account to your consumption-based logic app. Now, most of these connectors are now standard connectors. Some of these may slide off into the enterprise connector. I don't think any of these do, but there are standard connectors now that are fully available without integration accounts in both standard and consumption. That said, in order to use the AS2 decode, encode, etc., you would need to have your integration accounts to define your parties. So you still kind of need to have that set up. And the same with like the flat file and schema validation and transforms. In order to execute those, you would need to connect your consumption logic apps to an integration account. But those are freely accessible inside your standard edition logic apps. So that said, let's just jump in and see how we would set up a integration account if we were in consumption and wanted to do a transform. So I've jumped over quickly to the Azure portal. I'm already logged in, and this is just a quite simple integration account that I've set up. You can see here on the left, these are the options we have available: schemas, maps, assemblies. We can also set up our certificates here. We can set up private certificates here as well. Those actually have to be hosted in Key Vault, but you do reference them here inside your integration account. Partners and agreements. If we look at our partners and agreements and we click add, you're going to see partners not very exciting. Look at the agreements. You're going to see the look and feel is very similar to what it was in BizTalk Server. So if you're familiar with setting up parties and agreements in BizTalk, setting them up in Azure is going to make a lot of sense. I am unaware of any import tool to automatically import everything from BizTalk into Azure. Past projects, I've went in and just done it manually because there wasn't a whole lot of them. We have the ability to set up bash configurations and some Rosetta Net components as well. We're going to look quickly at the schemas component. I've uploaded two XML schemas here, and then you simply upload your transform here. And once I set this up in a consumption-based logic app, I would be able to access this schemas and maps and execute that transform. Now, in standard edition logic apps, schemas, maps, assemblies, these three components are just native. Let me jump over and show you what that looks like. Now I've just jumped over to a standard edition logic app that I actually created for another demo. And you can see, I just want to point out here that under workflows, you do have the ability to upload your schemas, maps, and assemblies. The key thing to point out here is that logic apps in standard are really like a top-level container. A logic app component can contain multiple workflows, so up to 10 or 20 or so workflows. These schemas, maps, and assemblies are going to be at the logic app top container level, so they are going to be able to be shared across multiple workflows. So if you had 10 or 20 workflows all leveraging the same schemas and maps, it's going to be great. If you had 100 workflows all needing the same schemas and maps, you're going to have to come up with a function-based solution or have that schemas and maps deployed to multiple logic apps across the solution. So that is kind of a caveat there. Or of course, you could always jump in and use an integration account to have them centrally located. But that would, of course, come with that additional cost. Hello, my name is Stephen Thomas, and this is another video in my series on Azure Integration Services and Hybrid Options. In this video, we're starting a new module all about the Azure Service Bus. Now, I've broken this up into several smaller videos so you can pick and choose what you would like to learn about. If you're new to the Azure Service Bus, this is a great place to start. Let's jump into what the Azure Service Bus is. First and foremost, it's the queue we've been waiting for. If there's one thing that's consistent in my over 24 years of working with integration solutions, is almost every integration solution seems to have a queue. Long ago, IBM MQ was the golden standard for enterprise queuing. Almost every client I worked with used IBM MQ. The big drawback of IBM MQ was, of course, the cost. It came at a pretty extensive price. Given the price of IBM MQ, sometimes the customer would build their own queuing infrastructure using SQL tables. This is a solution I've used many a times for smaller integration solutions, and this worked pretty well. With Azure, there's a new option that we have available to us. There's an enterprise-grade, low-cost option, and that is called Azure Service Bus. Now keep in mind that Azure Service Bus might not be the best option when dealing with low latency scenarios and synchronous solutions. Let's give a quick overview of the Azure Service Bus. First and foremost, the Azure Service Bus is a message-based, reliable messaging platform built in the cloud on Azure. It supports many common features that we would come to expect with a queuing infrastructure. This includes first in, first out support, duplicate message detection, basic publish and subscribe features by using topics, dead letter support, and peak lock support. Now, many of these features we're going to dive into more detail in later modules, but for now, just keep in mind that all these features are available for you inside the Azure Service Bus. Now, you do have a message size limit. The message size limit is 256K. If you need larger payloads than this, you could look at using a claim check pattern. This is an approach where you would write the payload of the message to generally Azure storage, and then pass a reference to that message around the Azure Service Bus. This is a common approach that I've seen in Azure Integration Services, and something I've implemented several times in the past, and this tends to work very well. Now, you can get larger message support up to 100 megs if you're using the premium tier. Now, with that said, let's take a quick look at our pricing options and what different tier levels we have for our Azure Service Bus. There's 3 different tier levels: Basic, Standard, and Premium. With Basic, it's something I've never actually implemented because it is quite in fact so basic. A Standard Edition comes at a hefty price of, wow, $10 a month. And if you need the premium features, which gives you zone redundancy and that larger message support, you're going to be looking at more around $700 a month. With that said, the vast majority of my clients do go with the standard edition implementation of Service Bus, and this runs you around 35 cents a day. If you look at other services inside of Azure, I feel 35 cents a day, the Azure Service Bus has to be one of the best values out there today. With this, you do get your queue support, obviously, as well as topics, which is going to add that pub sub functionality inside of your service bus. And we'll take a look at how to use that in our solutions in a later module, and it can come in very handy. So like I said, most clients do end up going with this $10 approach. So with that, we've seen just a high-level overview of kind of what the Azure Service Bus is. Let's jump right in and create a Service Bus namespace and go ahead and create our first Service Bus queue. Okay, I've now jumped into my Azure portal. I've already logged in. I've jumped to my live demo dashboard, and let's go ahead and jump into my resource group and see how we can create a new Service Bus namespace. We go up here to create, and I'm going to select Service Bus and come down here to create and give it a name, live demo, and the date. Going to create it in East US. And here you can select your pricing tier. If you'd like more information on the pricing tiers, you could click the Browse Available Plans and their features. But I know I'm going to jump into the Standard Edition Service Bus. At this price point, I don't see any reason to create a basic edition. I would always jump right in and create that Standard Edition Service Bus. And you'll notice a lot of other features here, such as geo-replication. This is a premium only feature, so it's grayed out. You're not able to select that. Let's go over to advanced. You can select your minimum TLS version. We're going to leave that as the default. If you wanted to give this private network access and set it up on a VNet, you would have the ability to do that here. Again, this is going to be a premium only feature, so it's not going to be available for us in the standard edition. You can set your tags, and you should always set your tags, such as a cost center, and give it some value. This will help you organize things later on, and you're going to thank yourself for it. And going to go ahead and review and create. And this will take it just a moment to do its validation. Then once its validation is complete, you'll see it at the top, and don't forget to hit create. Now it is going to take just a few minutes for this to create. I'm going to jump away and come back once this is done. Okay, now the deployment is complete. I'm going to jump to the resource by clicking this button. And here you can see my new service bus namespace that I have created. A few things we'll take a look at over here on the left side is kind of some overview information. You have your access control information here. This is to give you resource level access to the service bus namespace. This is going to be at the service bus namespace level, and you can add different role assignments and add different users here as you see fit. And under settings, you have your shared access policies. This is an older way to authenticate to some of the service bus and Azure resources, where you essentially have a name value pair, a resource policy to access these resources. This is commonly used in like BizTalk server, for example, when you're going to access service bus queues. In general, when I try to access the service bus namespace from other Azure resources, I'm going to tend to use essentially integrated auth or role-based authentication for those resources, which is very beneficial and simple to set up. But we do have this here. You can create new access policies if you need. And let's jump down here and see our queues and our topics. There's going to be nothing here. We're going to dive into topics in just a moment. But let's take a look at queues. If we wanted to create a new queue, we'd simply come over here and click queues. And I can give it a name. Just call it demo 08. And you can select your queue size. It goes up to 5 gigs, and this is how much data you can store inside your queue. We'll just leave it default. You have a bunch of properties you can set here, such as max delivery count. So this is the amount of time it will try to deliver your message, such as through a peak lock approach. After this amount of time, it's going to dead letter that message for you so that it doesn't keep trying. So if you get a bad message in your queue, it's not going to mess things up. You can set a time to live for your messages. Again, it's going to dead letter your message after this time to live in your queue. And you can set a default lock duration. So if you're doing a peak lock approach, which we're going to see in a later module, you could set that lock duration here. And at this time, it will expire that lock to allow somebody else to pick up, another worker to pick up and process that message. And here you have a bunch of features that you can choose to implement if you'd like. You have auto delete on idle queue. You have duplicate detection, which is pretty self-explanatory. Once you do enable that, you can set how long you want it to check back in time for duplicates. If it does find another one, it will not process it. We can enable dead lettering on message expiration. It'll tell you what to do with that message when it does expire. We can enable partitioning and sessions. These are both kind of advanced features. Partitioning will allow you to extend your messaging across multiple messaging brokers. This is a property that can only be set at the time you create your queue, and not something that you can edit later. So in this case, we're going to disable and turn off partitioning. Sessions allows you to essentially assign a session ID to create in-order message delivery across the queue. Sessions can kind of be thought of as a queue inside of a queue, for example. So if you wanted to correlate messages based on an order ID or something like that, you could do all that inside of a session variable. And you have the ability to forward messages to queues and topics. So with these settings, I'm going to uncheck these two, just create a basic queue and go ahead and click create. Now it takes it just a moment to create this queue, and now we're going to have access to our service bus queue. You have a lot of properties here, such as message count, dead letter count, max size, stuff like that. Let's jump in here and take a look at this queue in more detail. You have a nice dashboard, tell you your requests and messages that you have in here, give you a great overview of this queue. One of the best features, and something we're going to dive into more in our next module, is the Service Bus Explorer. This allows you to jump right here in the portal and read and write messages from this queue. So if you're testing this solution, it's a great way to send a message to the queue if you would like to. And the Service Bus Explorer has been around pretty much since the Service Bus came out many years ago, and it originally existed as a desktop tool, and that has recently been ported into the Azure portal. And we can look at under settings here, and again, we have our shared access policies. Now, this would allow us to define a shared access policy at the queue level. So if we wanted to define access to give a worker the ability to read and write messages from this queue and this queue only, we could come in here and set up that shared access policy here, and they would have the access to do that. Again, if you're using non-Azure clients such as BizTalk or something to access a queue, this would be very beneficial. Let's come over here to access control, very similar to what we saw before. And this allows you to define Azure resources and AD resources that want access to this queue, and particularly this queue, not the namespace. With that, we saw a really quick overview of how to create a service bus namespace and how to create our first queue. In subsequent modules, we'll dive into some of these other features, and we will take a look at how to read and write to these queues from Azure Logic Apps. Hello, my name is Stephen Thomas, and this is another video in my series on Azure Integration Services and Hybrid Options. This module, we're covering the Azure Service Bus. In this video, we're specifically going to talk about reading and writing to a service bus queue in Logic Apps. Let's get started by taking a look at the two different types of service bus connectors we have available to us. The first type is a built-in or in-app connector. This connector is only available inside of Logic App Standard. Since this is an in-app connector and runs in process with your Logic app, you're going to get the best performance and achieve lower latency using this connector. Plus, there's no additional transaction costs for using this connector in your Logic apps. The second type of connector is a Microsoft Managed connector. This connector is the only option if you're using Logic App Consumption. This connector can be called from any place. So if you're calling this in Logic App Standard and you're hosting that in your own data center, for example, you can still leverage this connector because it's going to make a call to the Azure data center to complete the call. Due to this, in general, this is going to be less performant than the in-app connector. Also, this uses a polling approach, so you're going to introduce additional latency based on your polling interval. There's also a per transaction cost, as we see with all Microsoft Managed connectors. While it is only a few fractions of a penny, that can sure add up over time. If you're looking for more detailed information about these two types of connectors, you can follow this link below. Let's dive into a little bit more detail about these connectors. First off, the built-in in-app connector. As I mentioned, it's only available in Logic App Standard. When you search for this connector inside your Logic app, you could see both types of connectors depending on your search logic. You want to select the one that is tagged in-app, as shown below, in order to select your in-app connector. Now, when using the Microsoft Managed connector, it's going to look a little bit different. You will see that there's no in-app tag to identify this as an in-app connector. This means that this is the Microsoft Managed connector. As I mentioned, this is your only option if you're using Logic App Consumption. Once you select this connector, and if you're using it as a trigger, you have to define a polling interval. This could be anywhere from minutes to seconds, or even days or weeks, depending on your use case. Another feature of the Microsoft Managed connector is that it uses what's called long polling. This means even though you define your polling interval as, let's say, every 3 minutes, for example, it will make a connection and actually wait for messages to arrive for the next 30 seconds. If no messages arrive in 30 seconds, it will end its connection and wait for the next polling interval. If a message does arrive, it resets the clock at 30 seconds and will continue to monitor for new messages. So even if you set your polling interval at 1 hour, for example, and if you continue to receive messages over time, This connector could continue to process messages much more frequently than your 1-hour interval. And we'll see this in action in our demo. With that, we took a quick overview of these two types of connectors. Let's dive into a demo and see these in action. I'm now logged into the Azure portal, and I've went ahead and created a Logic App standard that we're going to use for this demo. I've pre-created 3 separate workflows, one for testing our in-app connector, one for our managed connector, and one for writing our outbound messages. Now remember, the Logic App standard is a top-level container and can host multiple workflows. So in doing this, we need to think about how we're going to authenticate between our Logic App and our Azure Service Bus namespace. This can be done primarily in 2 separate ways. The first one is going to be managed identity. The second one is going to be a shared access policy. Those are the 2 main types of ways that we authenticate. I've now jumped over to my Service Bus namespace. And like before, I've pre-created a couple queues for us. They are our in-app, our managed, and our outbound queues to correspond to our workflows. Inside of these queues, you can set permission at the queue level. So you can set access controls and shared access policies on an individual queue. But when we're dealing with both types of Logic App connectors, we want to set it at the namespace level, the top level namespace level. So I'm going to go to access control. And I'm at a namespace level because it does say service bus namespace at the top and no individual queue information. I'm going to go add, role assignment. And I'm going to set this user to an owner of the namespace and going to select a managed identity. Go ahead and select my Logic App standard, and my Logic App queues 08 is the standard edition Logic App that I want to select. Say select and review and assign and click it again. And that's going to assign permission for all the workflows in that Logic App to have full access to this service bus namespace. Now, when we create the connection, we do need this host name, the fully qualified name to this namespace. I'm going to go ahead and copy this and just copy it to Notepad so we have it for later reference. And while I'm here, I'm going to take a look at the shared access policy. And I have one already created, LA demo. You could just add a new one. The shared access policies are very useful when using the managed connector and also when using like BizTalk server, for example, to access the service bus that would use these shared access policies. And here I've already created a new one that has full managed permissions. And I'm going to go ahead and just copy this primary connection string because we're going to need this when we set up our connection as well. Okay, now let's jump into our Logic Apps. And the first Logic App we're going to take a look at is this managed connector. We're going to take a look at this long polling and see how that really impacts things. So I'm going to go to my designer and add a trigger. And I'm going to search for service bus. And you can see here we have our in-app connector. And then after that, we have our managed connector. Has no designation of being an in-app connector, so we know that is our managed connector. This is the one we want to use. I'm just going to say when a new message is received. And here we're going to go ahead and create a new connection. I already have one down here that has been created when I ran this example before. I'm going to hit change connection, add new, just so we can go ahead and create a new service bus connection. I'm going to call it temp man for managed, and access key is how we're going to access this because it's the managed connector. And here I'm going to paste that connection string that I had copied to my notepad earlier. I'm going to hit create new. And in just a moment, it's going to create that new connection. And you can see here that it is using that connection that we see here. I can select my queue from my dropdown. You will get an enumeration of all the queues that are available. And I'm going to use my managed queue. And once I select that queue, we also need to configure the polling interval. Since this is the managed connector, I can do that down here under how often do you want to check for items. In this case, it defaults to 1 minute. I'm just going to set it to 1 day for the purpose of this demo. And then I'm going to go ahead and click save on our workflow. Now that's saved, I'm going to jump over to overview. And you can see that there's no executions of this workflow yet. So let's go ahead and send a message to the queue and then come in and trigger this workflow. I'm going to jump back to my queues and go to my managed queue. And in order to send messages to this queue, there's a nifty little tool called Service Bus Explorer. This first came out as a desktop tool when Service Bus first came out many years ago. It's now been incorporated for the most part into the browser, so it gives you a very good experience here. I'm going to send a message, and the body of this message I'm going to actually set to the exact time it is now, which is going to be 40 seconds now, and going to do a refresh. And sure enough, we see one message in this queue. I'm going to go to peak mode and peak from start. And here's my message. You can see the text is at 12:15 and 40 seconds, and nothing is happening to this message. Come over here. We'll do a refresh on our workflow. Sure enough, nothing's happened, no executions, just as we would expect. And I'm going to go ahead and hit run and take a look at what happens now. And we can see that did execute at 16 minutes, 12 seconds. Going to jump back over here, do a refresh. Message is gone from the queue. Let's go ahead and send another one. It's now 12, 16, and 34 seconds right now. And let's jump back over here again. This time I'm not going to run, manually trigger this process. We'll do a refresh. And sure enough, you do see that that did run again. So it is maintaining that connection for that 30 seconds for the long polling interval. So even though I had set the connection polling on here to be 1 day, once it does make that connection, it is going to keep it open. So now let's go ahead and wait 30 seconds past this last time, which is now. And let's go ahead and send another message and see what happens. And we'll do a refresh here just to make sure. Sure enough, no queue messages are there. And let's send it at 12, 15, and 25 seconds right now. Now, I do have a timer open on another window, so you can't see that in the background. And let's jump over here. We'll do a refresh. And that refresh has completed, and sure enough, it did not pick up that message. So it's going to be waiting for that next polling interval to execute. So we could come up here and run it again and pick up that message instantaneously. And again, it would restart our 30-second long polling. So that gives you an example of what it's like to use the managed connector. That experience is the same we saw here in Logic App Standard. Experience is going to be the same if you're using Logic App Consumption. So let's jump back to our workflows and our Logic app, and let's go to our in-app process here. We're going to jump to Designer, and in this case, we're going to add a new trigger. We're going to search for Service Bus. If I did want to select only in-app connectors, I could come down here and select a runtime, select in-app, for example, and it's only going to show me the in-app connectors. And I'm going to select the same one we saw before. Here, I'm going to give it a connection name, temp in app. And I do have to specify my authentication type. In this case, I'm going to use managed identity. And I do have to enter that fully qualified namespace to my service bus. I did paste it here in Notepad. And going to go ahead and create new. And that's going to go ahead and create our connection using integrated auth. So any workflow inside this Logic app is going to have access to that. Just like we saw before, I have access to all the queues. I'm going to say in app. And the big difference here is there's no how often should I check for messages. There's no polling interval that we define here. So I'm going to go ahead and save this. And let's see how the behavior differs when I send a message to this queue. So that is saved. I'm going to come down here to my queues. Going to select in-app. And in this case, go back to my Service Bus Explorer. I'm going to send a message like before. It is 12, 19, and 50 seconds right now. That's going to send that message. We're going to do our refresh. And once we do our refresh, we see that message has been picked up. We're going to jump back over to our Logic app, see how it is executed here. And sure enough, that did just automatically pick that up. It did take a little bit longer than I would have expected, just the first time kind of loading everything up and getting that to run. So let's go ahead and try that again. And we'll come over here. We'll send another message at 12, 20, and 56. 12, 20, and 54 seconds right now. And we'll do a refresh again. This time we don't even see the message in the queue. Jump back over here, do our refresh, and sure enough, pretty much instantaneously, it has picked up that message. So now that Logic app and the connections has all been loaded into memory, it did take about 20 seconds for that first message to get picked up. And that's definitely the longest I've ever seen it kind of take when I first started something up. I might have some other processes running, but in the future, now it's loaded in memory. This is going to run significantly faster than we would see with the polling interval based approach. So let's take a look at how we would write a message to a queue. It's equally as straightforward. I'm going to go to my workflows, go to my outbound workflow, jump over to Designer, and I've pre-built just a recurrence in a compose shape. Compose shape does nothing exciting, just says send from inside a Logic app. And let's come down here. I'm going to say send a message to my queue. So I'm going to add an action, select service bus. And I'm going to go ahead and use the in-app connector. I have connections created to both, but the in-app connector is going to give me the best performance, lowest latency, and no additional transaction costs. It's going to default to my in-app connection that I've already created. I'm going to go ahead and select outbound queue, and I want to set the content that I'm going to write to here. There's all these different other properties that we have, so we can set like message ID and session ID, stuff like that. We'll go into some of these in more detail in later videos. For now, we're just going to set the content, and I'm going to set this to the output of that compose shape. I'm going to hit save, and I want to go ahead and execute this recurrence. I'm going to go to overview and go ahead and hit run. And it's going to take it just a moment. Things seem to be running a little bit slower today, and sure enough, there it has executed. We'll jump over to our queues. And just there's our outbound. We're going to go to Service Bus Explorer. And just like we saw before, we have messages in our queue. I'm going to peek at those. And this is here. Sure enough, you see right now we have received this message. And it does say sent from inside a Logic app. So this was a very simple example of seeing the two different ways to read messages from Service Bus queues using the two types of connectors. We did take a look at the long polling for the managed connector and saw how we could use that and see how that really impacts things. And we also saw the lower latency of the in-app connector, which is generally going to be your connector of choice. And we took a look at how to write to that service bus queue. Now let's jump back to our slides to wrap things up. Hello, my name is Stephen Thomas, and this is another video in my series on Azure integration services and hybrid options. In this module, we're talking about the service bus. In this video, we're going to cover topics and subscriptions with Azure Logic Apps. Let's jump into what are topics and subscriptions. So topics essentially add one-to-many support for service bus queues. This allows a message to come in to one service bus queue and be routed to multiple destinations. This is done in a publish and subscribe mechanism where you set up subscribers, known as subscriptions, to listen to messages that come in on your topics. When working with topics and subscriptions, the sender will then send a message to the topic, and the receivers will receive from subscriptions. Subscription filters can be set up in two different manners. First off, there's SQL filters, which look very similar to a SQL expression, and you can access system and user properties by using sys dot and user dot. The second type of filter conditions is correlation filters. I also have a separate video that goes into these in more detail, and that can be referenced below. Let's talk a little bit more about the message structure of a service bus message. These are very similar to a message in BizTalk server, where you have a body of the message along with message context, which is metadata about the message. Service bus messages have a body and a properties segment instead of message context. Unlike BizTalk Server, which was able to automatically promote data from the body of the message into the context for routing, that is not available in the service bus. You have to promote your own messages, or essentially peek into the message, evaluate properties, and put them into the properties of the message to be used for routing. You could also ask the sender of the message to put the necessary routing data into the properties of the service bus message. With that, let's jump into a demo. We're going to see how we can set up a topic and set up subscriptions to receive messages from that topic. I've now connected to the Azure portal and I've already logged in. I've created a logic app called LAQs08 and I've pre-created 3 workflows. These workflows are one for all orders, one for orders over $500, and one for orders under $500. Now let's jump over to our Service Bus namespace and set up our topics and subscriptions. I'm over here under my main Service Bus namespace, which I created in an earlier video, and I'm going to go under Topics. I have no topics created now, so I'm going to click the plus icon to create a new one. I'm just going to call it Inbound Orders and accept all the defaults and say Create. This will take it just a moment to create. Once that's created, I simply click on the topic, and at the top here, you'll see the ability to add subscriptions. I can click on this icon, and I'm going to add a subscription for all orders. I want to receive all orders through this subscription and write them to, say, like an archive database or something like that. So I'm going to set all the defaults and say Create. And let's take a look at what was created for that subscription. I scroll down here and you can see I have one active subscription. I simply click on it and I can view the details of that subscription. Down here under Filters is where we define how we want data to route from that topic to this subscription. All of subscriptions come with a default, which is going to be 1 equals 1, which means every message will be routed to this subscription. In this case, that is what we want for this subscription because this is going to be the catch-all for all orders. So no changes are needed here. Let's go back and create 2 more subscriptions. Go back under my topic, say subscription, and I'm going to call this small orders. And we're going to define this as messages under or equal to 500. And I'm going to create another one called large orders. And this is going to be for orders over $500. I'm going to click OK to that. And scroll down here. You can see that now I have all 3 of my subscriptions. Let's start with the small orders first. I'm going to do the same thing we saw before. Look at this default filter. In this case, I want to delete it because we don't want every message to be routed here. I'm going to say add condition or add filter. And this is going to be defining the order amount. And here I have 2 different options, 2 different filter types that we talked about. I have the correlation filters, which I can define system properties to route on, or custom properties. Custom properties can be anything I want. Custom properties are not case sensitive in the name of the value, but they are case sensitive in the value of the value. So if I go order amount, for example, that would be not case sensitive. But if I did have a value for that was a string, it would be case sensitive. So in this case, I'm not going to use correlation filters. These are equal only conditions set up here in the UI. I'm going to use a SQL filter, so I have a little bit more control here. I'm just going to do user dot, and I'm going to call it order amount. And I want to say is less than or equal to 500. And hit Save Changes. And it's that simple to set up my order amount filter condition. Let's go back and do that same thing for our larger orders. Again, I'm going to delete the default filter and add another one. I'm going to call it the same thing, order amount. And again, I'm going to use filter, the SQL filters, order amount, and this is going to be greater than 500. Now, since these are integers, there's no case sensitivity for the value, of course, but the user-defined field as order amount is case insensitive. Just want to point that out, that there is a big difference between those two. And if you were using strings in here, it'd be like you were doing strings in SQL. You would use single ticks between your string, just like you would in a SQL expression. But we're doing integers here, so I'm going to leave that as is and click Save Changes. Perfect. Now let's jump back to our workflows and let's tie this into the service bus subscriptions that we just created. So I'm going to go under All Orders. In this case, I'm going to jump to Designer, jump into Add a Trigger. We're going to search for Service Bus, and I want the in-app Service Bus connector, and I'm going to say a message is available in a topic. And I was using a pre-built connection that I created in an earlier demo, so that's already there. And I can select my topic here. And once I select that topic, I'll be able to select the subscription that I want to route on. In this case, it's going to be all orders. So anything that routes to all orders, the subscription is going to be routed to this workflow. I'm going to hit save on that. And I'm going to jump over here and do the same thing for orders over 500. And jump into the designer, add a trigger, again, search for service bus. Take it just a second here. In-app connector going to a topic. Select my topic. This one is going to be large orders and hit save. And do the same thing for my orders under 500. Go into designer. And add trigger. Go to my service bus, in-app topic. And now we are all set for all of our orders. So let's go ahead and see this in action. I'm going to go back to my service bus namespace. I'm going to go to my topic here and use the Service Bus Explorer. This is a tool I introduced in the last video. If you're watching subsequent videos or previous videos, you'll see that here. I'm going to go send a message, and it doesn't matter what my body is. It's going to be order 101. And I can come down here and I want to set my custom properties. And I simply, if I wanted to set broker properties, you could do it here as well. And I'm going to add a custom property and what I call it order amount. Set that to a number. And in this case, we're going to say 250 and hit send. And let's go ahead and send another one. And doesn't matter what I put here. Custom properties, say order amount, number 750, and send. And now we would expect two messages to show up in the all messages workflow and one message in each of the other two. So let's go take a look. We're currently at our under 500. And it's going to take it just a second. Sure enough, we see our one message here and our under 500. Let's check our all orders. Sure enough, we have our two messages here. So both of our messages were routed here. And just to be sure, our over 500, we got our one message here. So what this quick demo illustrated here was how quickly and powerful it is to set up a topic and subsequent subscriptions. Now at any time, I could edit those subscriptions, change the way messages are routed to the service bus queues, and that could give you a lot of flexibility and control. There's also a lot of additional settings you can set on your subscriptions, such as dead lettering, what to do if no subscriptions are found, how to time out your messages, and stuff like that. So it's really feature rich and robust. The topics and subscriptions are just an extension of the queue infrastructure. So all the same features are available, even sessions. You can even have sessions. We saw here using the UI, a lot of this can be done programmatically via the API, via .NET as well. And you get a little more ability to set different features when you do it programmatically. There's also a desktop version of the Service Bus Explorer. And also using that tool, you have a little more features in terms of setting some of these SQL and correlation properties. So with that, I'm going to jump back to the slides. Hello, my name is Stephen Thomas, and this is another video in my series on Azure Integration Services and Hybrid Options. In this module, we're talking all about the Azure Service Bus. In this video, we're going to cover receiving messages via peak lock and dead letter support with Azure Logic Apps. There's two different ways to receive messages from a Service Bus queue using Azure Logic Apps. The first method is the receive and delete method. This does a destructive read of the message off the Service Bus queue. In doing so, messages are removed from the queue as soon as it hits the wire. This causes a possibility of a transmission failure could cause a message loss. So this is something you need to account for if you use this approach. This type of approach is great for low value or short-lived messages, such as messages that are like a stock quote, for example, that only have value for a very short amount of time. This is not the approach you would want to use for something like a customer order. That leads us into peak lock. Peak lock does a non-destructive read of the message off the Service Bus queue. This will lock the message and ensure that it is not picked up by another consumer that may also be receiving messages from that same Service Bus queue. Messages must explicitly be actioned on before the lock expires. This could either be complete the message, which would remove it from the queue, release the lock, which would allow another consumer to pick up the message, or move the message to the dead letter queue. Now, there is a maximum lock duration, which is 5 minutes. This is set by the Service Bus. If you need to hold the message longer than 5 minutes, you can explicitly renew the lock on that message. So what is the dead letter queue used for? Usually the dead letter queue is used for messages that are not able to be processed through the main processing channel. You would move a message to a dead letter queue to have like support take a look at the message, for example. The dead letter queue is essentially a second queue inside a queue or topic subscription. These can be managed through the queue itself, so you can see the messages in the dead letter queue right in the queue, or you can write a logic app process or some other consumer to receive messages off the dead letter queue of your main queue or topic subscription. This way you can automate the support process of messages in the dead letter queue. Now, there are a few pitfalls that you want to keep in mind when using peak lock. First off, there is a max delivery count. I believe the high limit is 5,000. It defaults to 10. This is the amount of time someone can take a lock on the message and try to process it. After the max delivery count, the message is moved to your dead letter queue. Another thing to keep in mind when dealing with peak lock is that inside your Logic app, a lot of times you have default retry policies. This could, in many cases, extend your Logic app processing time beyond your lock expiration. So you'll want to keep in mind when working with like the HTTP call, for example, if it hits a retry, what's going to happen to your lock on your message in your service bus. And we'll take a look at this in the demo. With that, let's dive into our demo. We're going to take a look at peak lock and dead letter support inside of Logic Apps. I've now jumped over to my virtual machine and logged into my Azure portal. I've already created a service bus namespace in a past demo, so I'm going to continue to use that. I'm going to add a new queue so we can take a look at some of these features that impact a peak lock. I'm going to call the queue peak lock. And first, we'll want to look at this max delivery count. As we talked about in the slides, this determines how many times the queue will allow the message to be retried before it will end up moving it to the dead letter queue. And you can see here it says, oh, the limit was up to 2,000. So anywhere between 1 and 2,000, I'm going to set this at 5. And the next setting here that is going to impact us is this lock duration. For purpose of this demo, I'm going to set this to 30 seconds. And you can see here it tells me it can be anywhere 5 seconds to 5 minutes. I'm going to go ahead and set it like that. The rest of these properties here don't really have any impact on what we're going to be talking about. I'm going to go ahead and create that service bus queue. And while that is being created, I'm going to jump over to our standard edition Logic app. And I've already created one here called Peak Lock Demo. I'm going to jump in and use this workflow and go into Designer. And under Add Trigger, I want to select an in-app connector and search for service bus. And here's my service bus in-app. And here I have my, when a message is available in a queue, this would be the read and destroy mechanism. So the single pole, and this is my peak lock. So I'm going to want to select peak lock. And you'll see here it's already populating with my queue names. That's because I'm using essentially integrated authentication. I've used managed identity for this logic app and already set that up in a previous demo. So all the authentication is already taken care of for me. If this wasn't here, you would have to create your connection for the first time. I'm going to say peak lock and hit save. And that's all I really have to do for that. But let's do something after I receive that message from the peak lock. Let's make an HTTP call. And one of the favorite sites I like to demo is http://stat.us. And this is a site you just do /200 and it's going to return you a 200. If you wanted to simulate 404, for example, you just do /404 and that's what it returns to simulate that. I'm just going to do a post to that location. And last, when I get a response back, go back into service bus. And in my in-app, I'm going to complete the message in the queue. To complete the message in the queue, you have to give it a queue name and the lock token, which is going to be a property when I first create the poll of the message for the peak lock. So it's when a message is available in a queue peak lock, and I want the lock token. Simply supply that lock token, and it's going to complete that message for me. So now I'm going to save that, and let's jump over to our queue. And I'm going to jump into the queue I just created, go to Service Bus Explorer, and I'm just going to go ahead and send a message to this queue. And it doesn't matter what I send. And hit send. And going to receive real quick. And you can see here everything's already completed out of here. Let's jump over here. What I'm just doing is showing you how that processed through our logic app. And that was picked up. It does get picked up almost immediately into our logic app because we are using that in-app connector instead of a polling-based connector. And we can jump in here. And we see, sure enough, it did run through our HTTP call and complete the message from the queue. And as we saw over here, it is verified there are no messages in the queue, nothing in our dead letter queue. So all's happy there. So let's take a look at what happens if we do hit a retry in this HTTP call and then build out our workflow here to be a little more resilient. So I'm going to come in here. I'm going to change this to a retry scenario, which is going to be a 500 error. And go ahead and save this. Going to go ahead and drop another message in my queue. Going to hit send. And do a refresh here. And we see a message in our queue. And this is going to represent the message that is going to be in our peak lock condition. So I'm going to jump back over here. Show our running workflows. We see we have one running here. And if we dive into this to get an idea of what's going on, so we have put a lock on our message in the service bus queue, which is what we saw, still having that message in the queue. And we are still running here on our HTTP, and we're going to be in a retry mode because we are returning that 500 error. Default retry policy is incremental, 4 retries over about a minute and a half, I remember right. But if you remember, we set that lock duration at 30 seconds. So that means after 30 seconds, the lock's going to release, and we're going to see what's going to happen here. I'm going to jump back here to my running workflows. Let's do a refresh. You can see here I have another instance that started. And then you can see they're pretty much 30 seconds apart, and that represents here exactly what I just talked about. So that lock had been released in the 30-second interval, and now another workflow was able to pick that up and consume that message. I'm going to let this continue to run for a few more retries, and I'm going to jump back in about 2 minutes. Okay, it's been a few more minutes now, and I wanted to show you what was running here. You can see here we have messages that are starting to fail. That's because the retry interval is finally at the end, so it's ending in a fail condition. Jump back over here, show you sure enough that message is still here. Delivery count you can see is 3. We'll do a refresh now. It's gone. The delivery message is totally out of there. If I go over here to take a peek at the dead letter queue, you can see my max delivery count, which I had set at 5, has hit. So it moved that message here to the dead letter queue, and it is my message high error case that I submitted. Jumping back over here, you can see this is definitely not the behavior that we would want in a peak lock scenario. These are failing out because it is airing out after the retry interval of that HTTP call. So let's go ahead and let's make some adjustments to our workflow so that our peak lock is going to work as we would expect. Just for the purposes of this demo, I'm going to come in here and set my retry logic to none for this. And retry policy was the default. I'm set it to none. So the first time it hits an error scenario, it is going to throw an exception. And now that I've removed that retry policy, let's think about what we want to do in this workflow. Well, we definitely don't want to complete the message. In this case, we want to just dead letter it right away and have somebody else take a look at why that message in this workflow didn't complete successfully. So I'm going to accomplish that by adding a new action here for service bus. And in my in-app, I'm going to do see more. And I'm going to select dead letter a message in the queue. And in this case, I'm going to select my queue. And again, I'm going to give it my lock token. But in this scenario, I only want this to happen if the HTTP request has an error in the process. So in this case, I want to adjust the run after properties. Can do that under settings, and under run after, I want to select an action, my HTTP action, and not select the complete a message in a queue. And I do want to change the settings so it is, if it's timed out, skipped, or it's failed, and no longer is successful. And you'll see my workflow has adjusted to account for this. So the happy path will be down here, complete the message in a queue. The unhappy path of any sort of exception will dead letter the message right away. So I'm going to save this. So this is kind of like what you would see in a try-catch scenario, in the sense that we're trying this and then we're going to catch the error down here, not really catching the error, just reacting to it. But peak lock is generally used with scope shapes in a larger workflow with a try-catch type of pattern there. So let's go ahead and let's run this again. I'm still set up to my error condition of 500 there. Let's send a message. Hi, test error 2. Go ahead and send that. Going to do a refresh here. And still we have our 1 in our queue, so it's going to be running for just a second. Do a refresh again, and now we see nothing in our queue, 2 on our dead letter. And we see here, sure enough, here's our second message. Test error 2, it did dead letter right away with no chance for it to run a second time. So we can come over here, take a look at our workflow. And we see this time that we have a failed workflow. But this time, instead of did identify this as failing, but then it did follow its compensation logic that we identified to dead letter the message right away. So now in this case, support be able to be notified of this event and dive in there and take a look at why this workflow had an issue. So this was just a quick look at using the peak lock inside of a logic app. And this used the standard edition logic app with the in-app service bus connector. There is a couple different connectors. I outlined that in a previous video, so check that out if you have questions. And with that, I'm going to jump back to our slides. Hello, my name is Stephen Thomas, and today's quick tips and tricks video is about setting SQL and correlation filters on a topic subscription in Azure Service Bus. Now, this is something that's been around for quite some time, I think 8 years or so, ever since, I think, since the service bus first came out. But it's one of those things I don't happen to do every day. So I tend to forget how to set these correlation filters and these SQL filters, which can be used for routing messages. So let's jump into the Azure portal and see how we can do this. I am now in the Azure portal, and I've went ahead and pre-created a service bus topic. You can see my topic here. I can dive into that topic, and you can see under subscriptions that I have pre-created several subscriptions. Most of these are used for other demos, but the one at the bottom is what we're going to look at, this route system. I can click on this subscription, and here I can add filter conditions. The filter conditions are how a message sent to this topic ends up at this subscription. Now, there's two different types of filter conditions. There are SQL filters, which is a more SQL style of filter, and then there's correlation filters. I'll talk about correlation filters first because they're the easiest. These are simply a name value pair collection. You have both system properties and custom properties. Custom properties are anything you might add to the message, and you can use these for routing. I'm going to go ahead and call this a demo. And you can see here under system properties, we have a subset of the available system properties that we can use as a correlation property. I could select something here like message ID and give this a very specific value. Now, these are all going to be equal conditions, so you can't do like or less than or anything like that. They're equals only. And they're also need to point out that the value is going to be case sensitive. So anything I would put over here is case sensitive. Message ID isn't necessarily a good one because that's very specific, but I might want to use a custom property like send to. Now, the property names themselves are not case sensitive, but the values are. So I'm going to say demo 1, and I'm going to go ahead and save this change. Now, if I add multiple properties here, it's going to create a larger and condition for that. In this case, I just have one. And let's go ahead and run this and see how we would route a message to this subscription. Now I'm going to jump over here and use a tool called Service Bus Explorer. This is an older tool that predates most of this functionality being added to the Azure portal. Now, a lot of this you can simply do in the portal, but I'm still old school, so I like this tool. Here you can see my topic. All my subscriptions are listed here. I'm going to go ahead and send a message to this topic. And go ahead and set a system property, a user assigned property, right here. I'm going to call it send to, purposely not matching the case. And I'm going to set demo 1, again, not matching the case of this value. I'm going to go ahead and hit start. And now in this case, we would not expect this message to be sent to the queue. I'm going to do a refresh. Sure enough, no messages sent there. Let's jump back to our Service Bus Explorer. Let's send it again. In this case, we want to send demo 1, hit start. And in this case, we would expect that message to be sent to the queue. And sure enough, we did end up getting that message. Now let's go ahead and let's change our filter here. Go ahead and delete this. And I want to go ahead and create a SQL filter expression. I'm going to call this demo SQL. Now, if you create both a SQL and a correlation filter expression, if any of those conditions are met, either of those evaluate for true, your message will be sent to that subscription. It doesn't add them together or anything like that. Inside the SQL expression, you have a lot more flexibility. This is a SQL-like expression here. And here, if you wanted to route on system properties that were not available in the correlation filter, you could simply use them here in a SQL filter. So let's go ahead and work on an example here. There's SYS dot type of properties, which is going to be system properties. And there's USR dot properties, which is going to be user properties. So these are going to be user properties. I'm going to set user property equal to send to, and I want this to be equal to my demo 1 again, like we saw before. Now I could also use the like condition here if I wanted to, and go ahead and put the percent signs around it like I would normally do in a SQL expression. If I wanted to have a more generalized condition, I'm going to leave this as equals. Go ahead and save changes. Jumping back to my Service Bus Explorer again, I'm going to leave it as is and hit start. And it should send that message again, just like we saw with the correlation filters. Do a refresh. You can see here, sure enough, now that SQL expression has been hit. Now, this was just a quick overview of how to set these SQL and correlation filters on your Service Bus subscriptions. And if you have any questions, please reach out and make sure you like and subscribe. Thank you.
Hello, and welcome to my channel. My name is Stephen Thomas. In this video, we're going to take a look at setting up Azure Logic Apps Standard step by step inside of VS Code. By doing this, you can run your Logic Apps Standard locally and not have to host them in Azure. I did a video similar to this over a year ago, and this video will show you how much more streamlined and simplified the process has become since then. I'm going to walk you through everything step by step, so no prior experience is needed. Let's jump in and get started setting up Azure Logic App Standard inside of VS Code in our local environment.
Now let's get started setting up our local environment inside VS Code so that we can run Logic App Standard locally. What you see here is a task list. I've created a task list of the 4 items we need to accomplish to get everything set up. I'm going to walk through these one at a time. Now, step 1, 2, and 3 are simply downloading and installing components. I've went ahead and pre-downloaded and installed these components already, but let's take a look at what they look like so you're familiar when you go to download them yourself. Something else that I should point out is that getting up and running with Logic App Standard locally is more of an art than a science. I find every time I go through this exact same demo, something different is going to happen. That is because there's so many different interconnected extensions in order to run Logic Apps locally that it's a pretty complex setup in order to get everything to run correctly. So if you run into an unexpected error here or there, I would just suggest shutting down VS Code, opening it up again, and start back where you were before. With that, let's take a look at what these components look like when we download them. The first thing you see here is Get for Windows. Now, this isn't necessarily required to run Logic App Standard locally, but later on, if you want to check in anything into your Git repository, you're going to need this installed locally. You simply click on the download link for Windows, assuming you're running Windows, and click here to download the latest edition of Git for Windows. You simply next through the screens, and then you'll have that installed locally. Next is VS Code. While it might seem simple to just download VS Code, there's actually 2 different types of installers, and they vary pretty drastically. If you see down here, there's a user installer, and then there's a system installer. The user installer is for anybody not running as a local administrator, and the system installer is for anybody that is running as an administrator. Now you're going to run into all kinds of pop-ups and issues if you install the wrong version. So make sure you know what your permissions are before you install VS Code. Now, why they didn't put system installer on one line, I don't know. I think they really need to resize this table because I personally find this a little bit confusing. But since in this environment, it's a brand new VM that I've created in Azure, I'm running as a local administrator, I installed the system installer edition of VS Code. Next, we need to download .NET components. The latest edition is .NET 9. I know some extensions will require .NET 9, so I went ahead and installed .NET 9. Some components inside of Standard Edition Logic Apps need .NET 8, so I also went ahead and installed .NET 8 of the framework. Installing both of these seemed to be the best approach when setting this up locally. Now that we have all our components installed, let's take a look at how we set up VS Code. I'm now going to jump over to VS Code. Now I'm inside VS Code for the first time. You could walk through here and configure everything for your liking. I simply chose Light Modern as a skin for this demo. Something else I should point out here is that VS Code doesn't automatically save anything. So one thing you might find when you're working through things here is you might want to adjust the auto-save settings. You can do that by adjusting settings on this bottom left-hand gear icon, and this will be all the settings for VS Code. Something else to keep in mind is if you have prior experience with Visual Studio, which is Microsoft's, I would say, enterprise development environment, that this won't necessarily transfer very well to VS Code. VS Code is a very free-formed and open editor and does a lot of things differently. Pretty much everything is ran through a terminal via a command line, unlike Visual Studio, where you would right-click and build, for example. So let's get started with installing the extensions we need to run Logic App Standard. I can do that over here by selecting Extensions from the left menu. And the first thing I want to do is install my Azure account extension. Do a search for Azure, and I could either click install here in the left menu, or I can select install in the main pane. I'm just going to select install here. And you can see some dependent components were installed as well. So Azure Resources was also installed as well. Next, I want to look for Logic App Standard. I'm going to search for Logic Apps. And you can see here there's two types. Let's take a look at consumption. Over here, you see the date. The last update of this extension was well over a year ago, back in 2003. And let's compare that to Logic App Standard, which was updated today. I'm actually recording this on 11/15. So there's a very new, fresh edition of this extension. That should give you a very good insight into which Logic App version I would focus my development effort on. So we're going to focus on Logic App Standard, and I'm going to click install. While this is installing, it's going to go ahead and install all the dependent components for me. This is a drastically different experience than what we saw a year ago, where we had to install all of these other dependent components manually. Now, this installation process is going to take about 3 to 5 minutes, and I'll jump back when that is complete and show you what it looks like so you know when you're done. Now, this editor will let you go do other things while this is downloading, but I would suggest simply waiting here and give it some time to make sure everything gets set up correctly. I'll be back in just a moment. Okay, that's finished installing now. The best way I found to determine when it's done installing, look for this dash channel 8 at the end, and this signifies one of the last components that is installed during the setup process. Now, just to make sure everything's running good, I'm going to close VS Code and open it again. I'll likely have to do this 1 or 2 other times throughout the course of the demo, and I haven't necessarily figured out why, but it just seems to get everything to work a lot better. Now, if you look down here on the right, you'll see a lot of notification windows popping up. And this is just different components of the extension looking for various artifacts. You'll get this pop-up, or you may get a pop-up about Azure Functions tools. I'm just going to say don't warn me again, because I don't want to have to worry about updating that at this point. Now, that's all we need to do to get up and running and building Logic App Standard in our local environment. So let's take it one step further and let's actually go and build our first Logic app. And we're going to build a Logic app that has custom .NET 8 code associated with it, because that is something that's pretty useful down the road. So to get started building a component, a Logic app, we click on the Azure icon over here in the left tooltip menu. And on this top toolbar here, we click the Logic app icon. Here we can go create new Logic app workspace. And I'm going to create a new folder on my C drive and put it here and call this live demo. I'm just naming the workspace. And here you can select just a Logic app project, which is going to be just your workflows, Logic app with custom code, which we're going to do, or a rules engine project. So for now, custom code. You have .NET Framework, which would be a 4.7, which would be legacy like BizTalk conversions. Would probably use that approach. We're going to do .NET 8. I'm going to give it a function name and a namespace. And here it's going to pre-populate a workflow for me, and that workflow is going to call sample code that it's going to create for me in the functions project. So I'm going to create a stateful workflow and call this live demo. Going to open in current window and say yes. And just like that, we see our workspace with our functions and our Logic app. You will get some pop-ups about network access. If this is your first time running it, I'm going to say allow. Also look for this allow parameterization of connections. You want to click yes to that down in this bottom right menu. If you miss it here, it's going to pop up a bunch of other times. So just make sure you catch it one of those times. And this is just saying it's starting the designer. Let's take a quick look at what we have here. We have a functions project. It's asking me to install C# development tools. I don't care about that right now. And this is just pre-built boilerplate code to call this functions project. I'm just going to set a breakpoint here so we can see what this looks like later on. Can come over here and it created a workflow for me. I can go to Open Designer and we can take a look at what the pre-built workflow looks like. And this is just a simple HTTP request response. And here you can see it's going to call my local function. This is red because I haven't built the components yet. So while it's set up to reference it, there's nothing there for it to reference. I'm going to close this real quick and let's build this component. I'm going to go to terminal, new terminal for functions project. And I'm going to do .NET restore. And when that's done, .NET build. Now, the build process here will build the components and move the required DLLs and metadata into our Logic Apps project. So it does a lot more than just build a DLL. It makes it so the Logic Apps know how to interpret that function. Now, functions can also have complex types. If you see here, there is a complex weather object that's returned from this function. So you're going to get full IntelliSense support for that when you're working in your Logic app. Now that is completed building, and let's jump back into our designer again. And it'll take it just a moment to open. And this time in the designer, you see that it's no longer red. We can now find and access our function. If I had more than one function in that project, you would get a drop down here. I could select the correct one. And let's just set a different zip code here, 90210. Okay. Now let's take a look at how we would run this locally. Again, I'm not connected to Azure at all, so all this is running locally. None of these connectors here are Microsoft managed connectors. If they were, I would have to be connected to my Azure account in order to create those connectors and make that connection call. But everything here is going to run locally in this process. So let's take a look at how we would start this process. I come over here to run and debug, and you want to attach to your Logic App project at first. And I'm going to start this using the green arrow up here. Now, this is where I said we need to restart again. I always get this error here about the local storage emulator not being set up correctly. Just hit cancel out of that. We're going to close, reopen VS Code. Now, likely when you're doing this, you won't have this problem. Again, like I said, it's an art, not a science. So just now I got to close all my little tool tips over here again. And now I do have to actually come in here and restore and rebuild again. But it went a lot quicker this time. Come back here, do the same thing again. This time it's already selected, attached to my Logic app. Hit the green icon on that. So in addition to attaching to the Logic app project, I have to also attach to the functions project. I can do that going view, command palette, and type in debug. And I want to select attach to a .NET 5 Plus or core process. And it's going to be this first one, this .NET EXE that has the Logic app function core tool component in it. Simply select that. And you can see here that now under my breakpoints, we see the breakpoint that I've created inside that function. So let's go ahead and run this. I can go back to this top Explorer icon, come down to my workflow, right click, go to overview. This is going to give you a nice overview page for that workflow, and I can run it right here. I could also call this function if I wanted to by using something like Postman. If I wanted to call it locally, I'm going to simply run trigger, and this is going to execute that workflow. And you can see here it jumped right in to this function, just like I would in any other C# component that I would build. I'm going to go ahead and just run this, have it complete, and jump back to overview. And sure enough, that execution completed successfully. And I can dive into this execution. And you can see here step by step all the components that were processed during this execution of that workflow. And I'd be able to dive in here and see all the details of that execution. One thing I should note is you see here, remember I changed the zip code, but what did I forget to do? I forgot to explicitly save the workflow. So that save wasn't committed. So that's one thing to definitely keep in mind. And you'll definitely run into this if you're new to working with VS Code. Again, let's come down here under settings, and I just search for save, and you can change your auto save settings here. Auto save is off. We could set it to on focus change, generally what I set it to. No need to save, simply exit out of that. And it's that simple to get set up locally with VS Code to run your Logic App standard in your local environment. If this has been helpful, please post a comment below and don't forget to like and subscribe. Thank you.
Hello, my name is Stephen Thomas, and welcome to my channel. In this video, let's talk about using Azure API management with Logic Apps. If you have used APIM with Logic Apps consumption, you know that it's a simple process to expose a consumption-based HTTP-triggered Logic App using APIM. You would simply set the API type to Logic Apps and then select the Logic App you want to expose. If you're using a Logic App standard, this is a little bit more of a tricky process. In order to expose your Logic App standard endpoints via APIM, you do have to do a little bit more configuration. It's definitely not that difficult, and once you see how to do it, it's going to make total sense. So let's jump into APIM and see how we could expose our HTTP-triggered Logic App standard workflows.
So let's take a look at how to set this up in APIM. First off, we're going to start by going to our Logic App standard and going to the Logic App workflow that has the HTTP endpoint that we want to expose. In this case, it's this one here called order status. I'm going to simply click on that workflow. And I'm going to navigate to the HTTP receive here and simply copy this URL. We're going to use this URL inside of our APIM when we go about setting up the forward into this Logic App. So I'm going to go ahead and paste this here in Notepad++. So the first thing I want to do is split out the root URL, which is this part here up to and including the /API. Everything after that is the information about the workflow that's going to get executed. You can see here it's the workflow name, triggers, the HTTP trigger name, and then some various information for authentication into that workflow. So I'm going to use both of these pieces of information inside of my APIM. So let's jump over to our Azure APIM. And this is just a consumption-based API management that I have set up. First thing I want to do is I'm going to go create a new API of HTTP type. I'm going to call it something like get order status. And right here in this web service URL, this is where I want to paste this first part of the URL. This is the same for all workflows that are inside that same standard edition Logic App. Because remember, standard edition Logic Apps can have multiple workflows hosted inside of a single Logic App. So this would be that root address into all the workflows in that Logic App. So with that, I'm going to paste that here in this web service URL section. Then I'm simply going to go create. And then here I can go ahead and create an operation. So I'm going to come over here and click add operation and give me some more room here. And I'm going to say order status and grab this. The name and put it as part of the URL is just going to be a post. And simply, this could be anything in this URL section, but I'm just going to use it the same as the name so it's easy to understand. Everything else I'm going to leave the same. I can simply click save on this. And that's pretty much as simple as it is to create the API and our operation. Now we need to essentially tie this operation to that specific trigger in our Logic App standard workflow. So to do that, I am going to now copy the back section of this URL, the piece after the API section, and I'm going to come back to my APIM. Now here's where it can get a little tricky. If you click on all operations versus clicking on your specific operation. Clicking on all operations, you'll define settings over here for all operations in that API. If you just want to edit a specific operation, you need to make sure you're highlighted and selected on that specific operation. So in this case, I'm going to make sure I have order status selected. I'm going to come over here to my inbound processing, and here is where I want to make sure I forward those requests to our specific workflow. You can see here under backend that it has automatically populated that first part of our Logic App workflow address right here for us automatically. And this will happen to all operations inside of this API. So now let's double check that we have our operations selected, and I want to do add policy. In this case, I want to rewrite the URL because I want to change it to send it to the destination. And then here I simply would paste in the back end of the URL for our workflow that I want this request to be sent to. Now, it's very important that you do it through this interface here and click Save, as opposed to driving in here to this inbound processing section and adding it here. It will encode certain values inside of this URL to make it work for your XML. So it's going to XML encode those. So unless you wanted to XML encode your stuff by hand, by going in through this front end tool here, it's going to automatically do that for you. So that can be a big time saver. So with that, that's really all you need to do to set this up. If you want to make sure what URL you want to use to test this, you can click on test. You can scroll down here, and here's going to be your request URL. So let's go ahead and give this a try. I have this set up in Postman over here. Here's a call into this logic app that bypasses APIM. I already have this set up. I'll show you what this looks like. And this makes a call in and just returns your order is in progress and gives the current date time. Now we want to see this go through APIM. And I'm just gonna, the old URL from when I was testing it. It's very similar. You can see it's a much cleaner, straightforward URL. And I'm gonna try this now. It's actually not gonna work because access is denied. So by default, there's security added to that API and APIM. So let's go ahead and disable that. You can do that under Design and under All Operations, under Settings. And down here, I'm gonna disable this token authentication. I'm going to save that. And something else I want to point out that can be useful is I'm going to go back to Design. And here under All Operations, it's very likely I want to restrict who can call this API other than individuals that might have a token, because I just disabled that token ability. I can come under Add Policy, and I can do an IP filter. And here I can add a range of IP addresses that are allowed to access this API. So let's add this while we're in here. And I'm going to go ahead and add something that is out of range, so it should not work. And I'm going to add all of this IP address range. And let's go ahead and give that a try again. And you see we got a different error. We got a 403 or forbidden error because now this is APIM blocking based on our IP address. So if we want to open it up to our correct IP address, let's go back into APIM. I'm going to edit this filter expression, and I'm going to set this within the correct range of where my IP for this virtual machine resides. Go ahead and save that. Now we're going to try it again. And this time you can see here it's successful. So it's very straightforward to expose your standard edition logic app workflows through Azure API management. And you can see here you get a much more friendlier URL. And now you have complete control over this API in terms of who can access it. You can set access restrictions, the amount of times they can call it. As you can see here, we set IP restrictions. You can also add token authentication and other types of authentication beyond what logic app workflows have. And most importantly, if that backend does change, you redeploy your logic app into a different name, for example, you simply can change it in APIM and don't have to let your consumers of that API even know that it has changed. So thank you for watching this video. Hopefully you've learned how to set up your API management with Logic App Standard, and don't forget to like and subscribe. Thank you.